Finish your time.
Hi, everyone. I welcome you to the second day of the YP Congress with the session on fluvial hydraulics and eco-hydraulics. I would thank the chairs for accepting to be online with us, Daniel Hayes and David Avanzo. And I think I'm just leaving the floor to them now. Enjoy the session.
Thank you, Arianna, for the nice introduction, and thank you. Good morning, good evening, good afternoon, depending where are you in the world. Thank you for connecting. I'm David Avanzo, researcher at the Karlsruhe Institute of Technology and member of the leadership team of the technical committee of eco-hydraulics of IAHR. And today with me is Daniel Hayes. He's a researcher at Boku University, Vienna, University of Natural Resources and Life Sciences. And he's currently the chair of EcoINET, the early career network on eco-hydraulics. We will try to reserve 5 minutes later on to introduce also this initiative of the young researchers. I'm very happy today to chair and listen to your contribution. Today, we in this session, we discuss fluvial hydraulics and eco-hydraulics. According to the main program, and I hope there are all the presenters ready, we have 11 contributions. And then there will be a coffee break where we open the discussion with you and we try to give you also some feedback. The housekeeping rule are that you are invited to pose your question directly in the chat, so then we can recall and start the discussion from there. And we will go directly through all the list of speakers. You have about 5 minutes, let's say. Let's try to stick to 5 minutes for each poster and presenter. And then, yeah, the hosting are managed by Arianna Varani and Manish Pandey, I guess. I can see them both here. So they will let us know if there is some missing speaker or something. So without further indications, I think we can start. So I'm happy to give this 5 minute stage to for the following poster: applicability of environmental DNA to examine habitat use of Japanese eels in small river estuary. There are many co-authors. Please, the floor is yours.
Can you hear me?
Yes.
Thank you. Hello, everyone. I'm Saki Mizumura from Tokyo Metropolitan University. Today, I'm going to talk about my research, applicability of environmental DNA to examine the habitat use of Japanese eels in a small river estuary. The purpose of this research is to investigate effectiveness of environmental DNA for assessing Japanese eel's seasonal dynamics, its habitats in a small river estuary, and its relationship with environmental factors. The study area is Nishimone River, a small river in Kesenuma City, Miyagi Prefecture, Japan. Water sampling points are shown in Figure 2, B and C. Water sampling was conducted in front of frame revetment in the estuary, which serve as potential habitats for aquatic organisms. Also, the other sampling point is in the river shown in Figure 2C. This study was taken place at high tides in September and November 2023, as well as in March, May, and July 2024. Environmental DNA analysis is conducted by water sampling filtration, DNA extraction, and PCR procedures following the protocols outlined in eDNA survey and experiment manual. Results of environmental DNA analysis are shown in Figure 3. In September 2023, in both river and estuary, environmental DNA were detected. In the estuary, eDNA concentration peaked at 502 copies per liter on the condition of highest water temperature. In November 2023, in the river, Japanese eels were absent when water temperature was lower than in September. On the other hand, eDNA were detected at 158 copies per liter in the estuary. In March 2024, Japanese eels were absent in the river, but they were present in the estuary with eDNA concentration 82 copies per liter. In May, in both river and estuary, eDNA concentration were detected. In July 2024, the eDNA concentration peaked at 124 copies per liter in the river. In the estuary, it had the second highest eDNA concentration, 2,143 after September. For these results, in the estuary, environmental DNA was detected throughout the year, with peak concentration in September 2023. In addition, during the colder months, November and March, environmental DNA was absent in the river, but still present in the estuary. Therefore, Japanese eels are more active and detectable in warmer water temperatures, which corresponds with their upstream migration in spring and early summer. Moreover, even at two locations, such as estuary and river, only 100 meters apart, seasonal changes were evident with distinct differences in environmental DNA concentration between freshwater and brackish environments. Thank you for your attention.
Thank you very much for your contribution, and you were perfectly on time. We move to the next one. As I mentioned, the question and answer will be later on in the second part. So the next poster is biomimetic design for flow hydrodynamic manipulation, tubular and hemispherical sponges.
Hello, I hope you all have a good day. My name is Masume and greetings from Amikabi University located in Tehran. Today my presentation is dedicated to how preserve coral reefs by using hydrodynamic science and biotechnology. As you know, coral reefs are marvelous underwater ecosystems, and actually They have a really important collaboration and interaction with human life. Because they are the source of cancer illnesses for production drugs, and also they are the source of production of petroleum and oil. Additionally, there are the houses for various fauna, flora, and coral colonies. They have the distinct role for progressing and improving the fisheries and also economics. So it is our duty now to save them against anthropogenic activities and also climate actions. For this reason, we observed coral reefs elements and discovered a brilliant sponge called Aplycina fistularis. This animal has distinct function and shape. It has a perforated cylindrical body which sucks flow from that body perforations, and then it pumps undigested materials and water from the top outlet. With this mechanism, this animal not only uses nutrition and necessary particles, but also remove pollutants and also other materials from its residency. So this circulating the marine patterns and also manipulating the hydrodynamics can help it to preserve for a long time on Earth. We designed two actually biomimetic sponges. One of them has a cylindrical shape and the other one has hemispherical shape. For examining our hypothesis in order to design a new device to enhancing the momentum exchange and also particle transportation, we simulated our designs in OpenFOAM with Interfoam solver, and also we uses Reynolds average Navier-Stokes equations for simulation. Our results show that cylindrical shape can produce von Karman Navier-Stokes downstream and after a lag, or maybe and after a recirculation bubble. And this issue can help to enhance turbulent kinetic energy and also momentum exchange downstream. However, hemispherical shape absorb the recirculation bubbles adjacent to the hemispherical toe. So as we anticipated, the turbulent kinetic energy enhances at the hemispherical location. So according to figure 2, as you can see, the turbulent kinetic energy near the hemisphere is much more than the cylindrical one. So it is maybe it is related to that hemispherical shape cannot hold the water column, and so the outflow or jets penetrating through the water column and enhances the turbulence. Additionally, as you can observe by 3D streamline process by OpenFOAM, we can draw a brilliant shape of flow patterns. And so again, according to figure 2, you can observe a giant and great recirculation bubble just behind the cylindrical biomimetic sponge. However, the mean velocity and also the recirculation bubbles are much smaller and lower in adjacent to hemispherical shapes. So for future program, we will try to enhance our programming, and also we may dedicate our program to learn and study more about how these devices can manipulate flow patterns and turbulent kinetic energy in order to enhance the momentum exchange. Thank you for your attention.
Thank you very much. Thank you very much for the interesting topic and presentation. We move now to the third poster. We jump back to hydraulic and fluvial context with assessing ECRAS and AI integration for hydraulic behavior analysis of the Ottawa River.
Hello, everyone. My name is Mohammed. I'm here to present my thesis, my master's thesis at the University of Ottawa here in Canada. It's 4 a.m. here, so I'm sorry about if I sound like tired or whatever. But so getting into the topic is the presentation that I have today. It's basically a combination of numerical modeling along with artificial intelligence techniques in order to predict different discharges based on climate change scenarios in the Ottawa River here in Canada. So just to start on that, recently we have noticed a lot of like in 2017 and 2019, we had huge floods in Ottawa that caused around $500 million of insured damages here in the city and surrounding areas. Keeping that in mind, we have developed a study that aims to develop a numerical model using high quality bathymetric data of the Ottawa River, which can be seen in Figure 1. It's just upstream of the city, which is good for us in order for us to predict how the water will be coming in and what level it's going to be coming in. We used hydrometric station data from the hydrometric stations provided by Environmental and Climate Change here from the Government of Canada website, along with bathymetric surveys that were conducted by one of our co-authors, Mr. Joe Kunderlich at the Mississippi Valley Conservation Authority. Using these these informations to basically calibrate and validate our model, we were able to get results ranging from around 3,000 meter cube to 8,000 meter cube per second. That is 2-year, 5-year, 10-year, 100-year, and 1,000-year flood, and then use those results from our model to feed into a artificial intelligence model, which is ELM, which is electronic learning machines. After we fed the data to the model, we actually had it predict future climate change scenarios based on SSP 285, and if I'm remembering correctly, which is SSP 585. And we got a good prediction based on our AI model also involved the integration of precipitation data and a lot of other like complex meteorological data, meteorological inputs that were used in order to predict, along with the water levels that we were getting from our model, to predict how the ELM was performing. And it gave us a good value of, like if we look at Figure 2, which shows the time series of comparisons for observed and predicted discharges by our models, we got pretty accurate results with our square values coming around 0.73 and 0.7 in the training and testing pages, respectively. It showed a good indication, but we also noticed that when it came to extreme events, when we had discharges that were going above 5,500 or 5,000 meter cube per second, which is what we anticipated which what Ottawa faced in the 2019 flood, May 2019 flood. Our model wasn't very accurate. It either over-predicted or under-predicted the results. So that is something that we will be taking forward and trying to fine-tune our model, or maybe using another type of AI integration, which is either GMDH, group method vectoring, or FMDH, which are other techniques that are being incorporated along with numerical modeling in order to predict future discharges based on meteorological and hydrometric data. So our study was pretty what we expected, but now it is something that we want to build on with in the future, combining different artificial intelligence techniques in order to predict discharges and water levels, and prospectively move forward with 2D flow analysis as well, so that we can predict floodplain widths and depths that are being affected around the city, and plotting those hydrographs in their details. Thank you for listening, and thank you for the opportunity.
Thank you very much for this nice presentation, and thank you. We move on with automated detection of active channels of gravel braided rivers.
Hello to everyone. I'm Valeria Guadagno, and I'm PhD student from Italy. I'm going to present my work. I'm trying to solve the problem of characterizing the geometry of a braided river. This is not simple due to the remote location of several gravel bed rivers and their inaccessibility during the floods. I used interferometric data to understand, to identify the number and width of active channels. My study site is the Trionto River in southern Italy, in Calabria region. In the figure 1b, we can see the interferometric data with the green circles. Each green circles or permanent scatter indicates a not moving point. It means that the satellite recognizes what it sees each time it takes the ground. It loses the signal when there are fast changes in what it observes, or if it water or vegetation. This means that where we see a high number of green circles, we have a stable part of gravel bed plain. Where we have a few green circles, something happened. I define a procedure to understand where is the transport, the active part. My procedure is divided in 4 steps. The first one is to identify the vegetation, to delete the vegetation from mobile zone. I divided my area into a 4 meters for 4 meters grid, and for each cell of my grid, I compute the stability index. The stability index can say us which part is stable, and his value is higher, is 1, or unstable or moving part, and his value is more or less like 0, or it's 0. When I define for each cell a stability index, I define also a threshold. This threshold gives me a limit from what I think is moving and what is stable. Once we obtain 20 matrix with binary value 0 or 1, what is mobile or what is stable, I can connect every mobile part to identify the connective path, my active network. But the final objective of this work is to identify the same network that I found with my manual procedure with an automatic procedure based on a connectivity tool. This tool needs an input. We give the 20 matrix binary matrix as an input, and this tool give us an connectivity index. This index is 0 if is disconnected. Is 1 is very likely connected. Obviously, it needs also geometric rules like path width, span, and path length. The graphic representation of path width and the span is in figure 3. The path length is the length of a window where we calculate the connectivity. In the figure 4, we can see the difference between an path length of 40 meters and 100 meters in the upstream part and the downstream part. These are preliminary results, but in any case, we can see that these first results fit not so bad with my active channel network that I found with my procedure. So now we are trying with other parameters to find the better solution. Thank you for your attention.
Thank you very much, Valerie, for your presentation. And we move on to the next one. This is the last one I introduced, and I passed the word to my colleague Daniel. So now we hear about bed scour induced by partially embedded pipelines crossing rivers and streams.
Hello, everyone. My name is Lucas Celia, and I'm a master's student at Queen's University in Kingston, Ontario, Canada. And today I'll be discussing my research involving bed scour induced by partially embedded pipelines crossing rivers and streams. So pipelines are considered one of the safest methods for the transportation of oil and gas that are not accident-free. They cross many rivers, and incidents of failure prove that they can pose a great environmental threat. During flood events, the sediment at the bed of a river may erode and expose a buried pipeline. Even the smallest exposure of the pipe may induce significant scouring of the riverbed, potentially resulting in the pipe becoming free-spanning and being exposed to loads not considered in its original design and often failure. This work presents the first results of an ongoing investigation focusing on the local scour beneath partially buried pipelines placed perpendicular to the flow direction. The work addresses an important gap in the literature, being that at present only one method is available to predict equilibrium scour depth under such conditions, this being a graphical method produced by Mazza in 1987. 2 experiments were carried out in a 21-meter-long rectangular flume at the Water Research Laboratory of Queen's University, and the test section of the flume consisted of a 3.4-meter-long and 0.2-meter-deep layer of very coarse sand with an average grain size of 2 millimeters. Upstream and downstream of the sand section consisted of gravel, and each test had a duration of 5 hours to ensure that equilibrium conditions would be met, and tests were conducted under clear water conditions. A circular pipe with a diameter of 4 centimeters was mounted across the flume, perpendicular to flow direction, and 2 embedded depths of 1 and 2 centimeters were used. The scour hole and free surface was captured at selected intervals throughout and at the end of each test to record the scour development. And figure 2 was a GIF that unfortunately is not working, that showed the scour development for test A2 over the 5-hour period where the pipe is buried 2 centimeters into the bed, but instead we have a great image of its initial conditions. And the average flow velocity and flow rate was estimated from local flow velocity measurements. So the measured values of equilibrium scour depth normalized by the pipe diameter, which will be referred to as E over dP, were plotted in the graph by Mazza, as shown in figure 1. The focus of this comparison lies within the section of the graph where E over dP, or the x-axis, is less than 0, where the observed equilibrium scour depth in both tests was approximately 3 times greater than that suggested by Mazza. The large deviation of the test results from the curves presented by Mazza suggested that the dataset used to create the graph may not have included tests with partially buried pipes, with the curves for E over dP less than or equal to 0 being a result of a mere assumption. But at the time, we are unable to confirm whether this is true, as the dataset used by Mazza has not been made available for review. But in conclusion, the graphical method by Mazza yields a result underestimating the equilibrium scour depth by a factor of approximately 3. Although conditions in the present experiments were rather limited, This result is concerning given the practical significance of the topic and stresses the need for further research. But with that, this concludes my presentation, and thank you very much for your time and attention today.
Thank you very much. Thank you.
Thank you, Lucas, also from my side. And I'm happy to be introducing the next speaker on the topic of the evaluation of the two-dimensional hydrological model, HEC-HMS in a Mediterranean semi-arid basin. The floor is yours.
And good morning, everyone from Spain. My name is Alberto Hernandez. I'm from the Polytechnic University of Cartagena in collaboration with Drs. José María Carrillo and Juan Tomás Bermejo. I'm going to present you our study on the evaluation of the two-dimensional hydrological model in HEC-HMS in a Mediterranean semi-arid basin. For a context, this research is part of a project that we have with the Cartagena City Council that examines the Albujon-Rabin Basin, that is the largest tributary to the Mar Menor. This study area in the southeast of Spain is characterized by a significant climatic variability, scarce and seasonal precipitation, and a high rate evapotranspiration. That complicates the hydrological modeling. We focused on channeled upper section of the basin, and we analyzed the land use that is dominated by agricultural use, and we applied the curve method under the dry and normal antecedent moisture conditions. The methodology that we do is we use the RAS mapper that was used to create different type of meshes that then were exported to HEC-HMS to evaluate the computational times and the results with the bidimensional modeling. Then also we created a semi-distributed model in order to make a comparison with the bidimensional modeling. We make a sensitivity test on computational time that showed that the variability of the different current numbers in this software is not relevant. And then the bidimensional model were run for its antecedent moisture conditions, and the semi-distributed model was also tested. We use the curve method number of the soil conservation services for infiltration with the two antecedent moisture condition, dry and normal. You can see here the study basin, and the results. We simulated 4 different types of meshes from coarse to fine with these results in this table. We choose for the comparison with the semi-distributed model the mesh height of 200 meters due to the less required time calculation and the similarity results with the other type of meshes. In the comparative between the bidimensional and semi-distributed models in HEC-HMS with the two types of cum number, the dry and the normal moisture conditions, we can see that the bidimensional approach reduced the peak flow error to only 2% of the rain of the gauge that we had in the basin. And we see that the dry antecedent moisture condition in this type of semi-arid basins yield the most accurate results, with better results in general than the semi-distributed models. And so the conclusion that we extract in this study are that the antecedent dry moisture conditions yield better in the Mediterranean semi-arid basins, and the use of the two-dimensional diffusion wave in the model in HEC-HMS provides more accurate results compared to the traditional semi-distributed methodologies that is used in this type of software. Thank you so much, everyone.
Thanks, Alberto, for your presentation. And I'm happy to invite the next speaker, Ali Khalili, on the topic of investigation of wood accumulation effects on river morphology around bridge piers.
In the name of God, hello to all professors and audiences. I am Ali Mahdian Khalili, a PhD candidate of water engineering and hydrological structures at Babul Mishirwali University of Technology in Iran. Our research is investigation of wood accumulation effects on river morphology around bridge piers. Why we should investigate this research? Because wood accumulations can move from upstream of the river to the human societies and infrastructures, and it may get stuck upstream of the bridge piers. And also in literature review, we can found that the most likely shape of the wood accumulation upstream of the bridge piers can be a rectangular shape. Because of that, in our experimental model, we considered a rectangular shape in with the box configuration, and we considered two wood accumulation cases, including the partially submerged condition, uh, which is higher than the sediment surface of the sand, and also we consider the fully submerged condition debris, which is exactly on the sediment surface. As you can see in figure 1, we have our physical model or our experimental configuration. We use a rectangular box, and also we fill it with pieces of wood with a thickness of 1 to 5 millimeter, and we use an apron at the beginning of the setup to develop the flow. We use sediments with uniform, which is the D15 equals to 0.82 millimeter. The approaching flow depth was varies from 0.04 to 0.09 millimeter under the constant condition of discharge equals 6.25. As we can see in figure 2, the flow changes upstream of the bridge pier because of the debris box. In results, we achieve all the characteristics of the score hole, including depth, width, and length of it, as you can see in figure 3. And in 3 cases, we have the model 1 is pier only, and the model 2 is pier with fully submerged, and the model 3 is partially submerged with bridge pier. As we can see, the maximum and minimum values of the variation ratios compared to the pier alone for the cases submerged and partially we computed. And as we can see, for the fully submerged condition or debris, we can have the reduction in the depth of the score hole with the value of 40%, and also we can see the maximum and minimum values for the depth, width, and length of the our models. I want to highlight the main conclusions of our work. We can see that the maximum depth, width, and length of the score hole in all cases of our models, including the pier alone, fully and partially submerged debris, increased by increasing densimetric fluid number. Also, we have 73% increase in the partially submerged for depths of the score hole, but in the fully submerged wood, we have a decrease with the value of 40%. And also for the width and length of the score hole, we have increase in all cases with the maximum value of 182%. And for the length and for the width and For the length, we have 50% in fully submerged condition debris. Thank you for your attention.
Thank you very much for this presentation, keeping in time also. Moving on to the next one. So the next presentation, it has the title on numerical simulation of subcritical open channel flow in the presence of rigid vegetation. The floor is yours.
Hello, everyone. My name is Theodora Kalariti. I'm a graduate from the Civil Engineering Department of the University of Peloponnese in Greece, and I'm going to present to you a part of my thesis study in the topic of numerical simulation of subcritical open channel flow in the presence of rigid vegetation. So the aim of this research is to examine how the presence of submerged rigid vegetation affects the flow characteristics in open channels. With this purpose in mind, a 3D turbulent subcritical with a Froude number of 0.2 open channel flow with submerged rigid vegetative stems fixed at the bottom of the channel was numerically studied. This is quite a low flow, which is identical to that found in river flows. For this simulation, the rectangular channel was approximately 37 meters long and 1 meter wide, with a bottom slope equal to 10 to the minus 4 and normal flow depth equal to 0.189 meters. The vegetative stems were modeled as vertical, rigid cylinders fixed at the bottom of the channel. Regarding the arrangement of the stems, a series of 3 equally spaced vegetative stems was positioned transversely at the center of the channel. As far as the characteristics of the stems are concerned, their height was equal to 1/3 of the flow based on the normal depth of the corresponding open channel flow, and the diameter of each vegetative stem was set equal to 0.015 meters. The numerical solution of the governing equations was based on a finite volume discretization using the CFT code ANSYS Fluent. The governing 3D Range equations were solved in the steady-state mode, while the standard K-epsilon turbulence model for the turbulence closure and the VOF method for the free surface treatment were employed for the numerical simulation of the flow. Moving on to the results, in Figure 1a, the vertical distribution of longitudinal U velocity upstream and downstream of the stem at the center of the channel is shown. The numerically predicted results are compared with the corresponding U velocity distribution for the flat bottom without the stems. We can see that both upstream and downstream of the stem, the velocity magnitude decreases at a flow depth equal to the stem's height. In contrast, the upper non-vegetation layer reasonably follows the logarithmic law. Specifically, the vertical velocity profile for the submerged vegetation layer shows an S-shaped curve with its inflection point close to the stem's height. In Figure 1b, the vertical distribution of the turbulent eddy viscosity structure upstream and downstream of the stem at the center of the channel is presented. The numerically predicted results are compared with the corresponding eddy viscosity distribution for the flat bottom without the stems. The same general behavior as that of the velocity was observed for the vertical eddy viscosity distribution, where higher values are calculated upstream of each stem. Figure 2 shows the turbulent eddy viscosity contours at the center of the channel at the vertical plane and along the channel at mid-vegetation height. Based on the numerical study, it is shown that the presence of the submerged vegetation has a substantial impact on the structure of turbulence, causing an increment upstream while downstream decreases in the neighborhood of the stems. Additionally, higher eddy viscosity values are calculated at the near crest area of each stem. Finally, based on the numerical simulations, it is concluded that submerged vegetation substantially influences the flow field in an open channel, resulting in a decrease in velocity magnitude within the vegetation layer, while the area above remains nearly unaffected. Similarly, the presence of submerged vegetation notably affects the turbulent structure, resulting in higher eddy viscosity values upstream at the near crest area of the stems. Finally, the subcritical flow leads to a slight free surface drop where the stems are located. And with that, the presentation is complete. Thank you for your attention.
Thank you, Theodora. For our next presentation, we are staying with the topic of vegetation, but moving outside of the water. And the next topic has the title Repairing Vegetation Dynamics derived from spectral indices and field measurements.
Hello, everyone. My name is Yiwei Guo, and my topic is about repairing vegetation dynamics that derived by spectral index and field measurements. I'm Yiwei Guo. I'm from Institute of Geography, Polish Academic of Science. Under the background of the climate change, more and more floods happened, and flood has caused widespread damage. Currently, almost 12% Europeans live in the flood-prone areas and cause about 56% dies which related to the flood. Therefore, effective flood management is essential to development. Hydrodynamic models are the basic and important tools to represent the flood process. However, the accuracy of the simulated results is highly influenced by the input parameters, particularly the roughness, which will obstruct the floor and make the water level increase. The roughness is usually affected by dynamic vegetations, but most models are not take the vegetation into the consideration. They just simulate the discharge of water level, assumption that the water is clean. Generally, roughness is obtained by experience formula or experiments, which is not so accuracy and sometimes is very time-consuming and money-consuming. With the help of the remote sensing, the long-term and large-scale data can be accessed easily. Therefore, the aims of this research is to build a relationship between the multi-spectral index, such as the NDVI and the field measurement vegetation conditions, hoping that the vegetation-related roughness can be estimated directly by the remote sensing data. The study areas of these researchers are two regions located in the Po River in Italy and the Wisła River in the Poland. They are two of the largest watershed of the Europe. The Po River is the largest water source and the longest river in the Italian, and the Wisła River is the fourth longest river in the East Europe. They are both usually have their high water level and easily occurred the flood events. This as this research is very beginning research, the methods are relatively simple. This studies process the NDVI data on the Google Earth Engine platform and do some field measurements to get the vegetation conditions. The Google Earth Engine is a platform that allows users to get access to almost all the open access data set and allow users process them on the platform with a very high speed directly. After getting the NDVI value and the vegetation conditions, I try to build a relationship cover between the vegetation height and the NDVI. And for the results, by the field measurements, I find that most of the vegetation along the rivers are similar. So when I process the relationship, I just put the data of two watersheds together to do the calculate. And I also find that the vegetation diameter is all of the vegetation diameters are around the 2 mm. So I just select the diameters of the vegetation in these two study areas as 2 mm, and the relationship cover between the vegetation height and the NDVI is shown as the equation on the poster. And this is all my findings by this method. And in my next step, I would use the Daft 3D FM models to evaluate the ability of the calculated roughness in simulating the discharge and water level to see whether the 2D hydraulic models, the ability of the 2D hydraulic models will be improved if I use the more accuracy vegetation parameters, roughness parameters. Thank you all. This is all. Thank you.
Thank you for this presentation on remote sensing and repairing vegetation. The next speaker will tell us, Bartolome, on testing the BIM methodology in fluvial engineering.
Good morning, everyone. My name is Bartolomé Morote Sánchez. I'm a PhD student from Polytechnical University of Cartagena in Spain, and I'm going to present my work about testing the BIM methodology in fluvial engineering. In this study, we investigate the application of building information modeling in river engineering, and we focused on the design of an urban channeling of the Ebro River in Spain, in the city of Zaragoza. BIM methodology is well known in other aspects of civil engineering like roads, but in fluvial engineering it's not implemented, so we are going to test. One of the advantages of BIM methodology is that we have all the information in one model: time, cost, the 3D design, sustainability, and also the management of the infrastructure. So first of all, we have to select the BIM program, and we are going to use Civil 3D, that is from Autodesk. And the channel design parameters include the digital terrain model of 5 meters grid, an average flow of 230 cubic meters per second, and the average width of main slope 80 meters, and the average slope 0.1%. On the right side, in figure 2, we have the result of the channeling obtained in Civil 3D. And we can see that the channel is moved from the river to the right path. We decided to move the river because there are some houses near the river and road, and the main thing of the channelization is protect that zone. In figure 2B and 2C, we can see the cross section of the channelization and the subassembly of the cross section of the channel. The subassembly is the name of the cross section in Civil 3D. The main conclusion that we have achieved in this presentation is that the elements available for the design channelization in fluvial engineering are not adapted. That's why all that program like Civil 3D and other programs of other companies are focused on roads, trains, and there are not specific elements for river engineering. There is an option of creating them in a program of Autodesk that is, the name is Subassembly Composer, but it's not an easy program, so we need a lot of time to take in the program and a great knowledge to create a cross section of a river. In my opinion, the main disadvantage is there is no hydraulic modeling programs linked in current BIM software. For example, we cannot run HEC-RAS in Civil 3D, modify the cross section, modify the plan view of the river, and then run again HEC-RAS. We have to design the river in Civil 3D, export to HEC-RAS, import the results, and it's not an easy way to work. So that's all. Thanks for your attention.
Thank you a lot for this presentation. We're coming to the final presentation of this session before the coffee session and the coffee part and the question and answers. So I'm happy to invite the next speaker, Annika Govil, on variation in scour depth with a triangle splitter plate, showing us a numerical study.
Hello, everyone. I hope I'm audible.
Yes, you are.
Yeah. Good morning, everyone. My name is Anika Gobel, and I'm a final year undergrad student at Shiv Nadar University in India. Today, I'm excited to present my research on variation in scar depth with the triangular splitter plate, which is a numerical study. As we all know that bridge pier scar is one of the leading causes of bridge failures worldwide, my research shall focus on using a triangular splitter plate as a countermeasure, which will help us reduce scar depth around bridge piers. My findings suggest that this simple addition can significantly enhance the structural stability of the bridge model. Talking about my objective, the main objective of my study was to evaluate the potential of a triangular splitter plate in redirecting flow and minimizing turbulence around bridge piers. This is especially critical for increasing the lifespan of bridges, especially in sediment-rich environments. My simulations were conducted using the computational fluid dynamics, that is your CFD software known as Flow3D, which is a cost-effective way to test hydraulic performance before we implement large-scale projects on field. So I incorporated the RNG turbulence model, that is your renormalized group turbulence model for flow, and the sediment transport model for the sediment dynamics. As you can see in figure 1, that was my numerical model setup, where I modeled two circular bridge piers, each 6 centimeter in diameter and kept at 0.42 meters apart on the sediment bed. The triangular splitter plate was made on AutoCAD and then imported to Flow3D, which was of a height 0.4 meters. The boundary conditions, the simulation included upstream velocity inflow and downstream wave outflow. Talking about the mesh details, that how accurately we got the results was the mesh size of 0.004 meters, which ensured precision in capturing flow behavior and sediment transport. So this total setup allowed us to observe how splitter plate influenced flow patterns, sediment movement, and scar depth respectively. Moving on to the results, as we can see in figure 2 and 3. Without a splitter plate, the second unprotected pier exhibited large recirculation zones and increased turbulence, which led to greater scar depth, while the first pier, which was still protected with the triangular splitter plate, redirected the flow outward, reducing recirculation zones and promoting downstream deposition. So these findings demonstrate that splitter plates can significantly help in mitigating scar by disrupting the horseshoe and wake vortices, which are the two primary drivers of scar. In conclusion, we can say that triangular splitter plates effectively reduce scar depth around bridge piers, which help us improve the structural stability of the structure. And also they can help, they achieve this by minimizing the turbulence and redirecting the sediment deposition at the downstream section. My research highlights the potential of splitter plates as an inexpensive and practical solution for enhancing the resilience of bridges in sediment-rich waterways. So thank you for taking out time to hear about my research, and I'd be happy to answer any questions or discuss that how this work can contribute to safer bridge designs. Please feel free to reach out via the contact information as well provided on the poster. Thank you.
Thank you very much. Thank you also for all the authors. We kept perfectly in time. So we're at 11 o'clock now, Central European time. And now we have another 30 minutes to discuss these topics with each other, talk about fluvial hydraulics, ecohydraulics. Also in general, we had a variety of different sessions. We had a lot of numerical studies. We had some studies looking into biotic components, vegetation, fish, so environmental DNA, studies also looking at remote sensing, river morphology, and stuff like that. So basically now we have a time where we can we invite all the panelists. Thank you for opening your videos. And we encourage all the participants. So there's a question and answer chat where you can write your questions in there. And I think the first one was actually already answered. I think, thank you on that, on the eDNA. Oh, 2 questions were answered. So basically, yes. So we encourage everyone to ask questions to the speakers.
Maybe meanwhile, attendees elaborate their question or they think through. I can start with some comment and maybe general question. Thank you again for participating, all the speakers. It was very informative. I took a lot of notes and I will have plenty of questions. I'm sure there is no time to go through all of them. And then if you allow, I have also some suggestion, some general comments for the speakers that that maybe it will help you in the proceeding of your career. Let's start. Just a general question I throw to you, and maybe you can comment differently. You are, let's say, young researcher, young practitioners working on the domain, and you presented quite some new techniques, for example, environmental DNA, but also artificial intelligence integration, use of remote sensing, so kind of new technologies, but also more consolidated, like CFD simulations, even quite complicated CFD simulation, 3D. So how do you feel regarding the learning process of these different technologies? You were, as we say, learning by doing, or you feel you had a good training from education, from courses, from your master courses, or it's something that you felt you were learning and failing by doing and so on and so forth? Can you comment on this?
Maybe if you
yes,
ask
please.
for maybe you mean the eDNA analysis is the new technology for the knowing the fish existence in a river. You mean?
No,
right?
my question, if I address to you, is how you learn about this technique. You learn during your study, or you receive you found some courses around the world, or some workshop, or how did you learn this technique? Do you think there is a good offer for learning, or you were stuck with learning by yourself, let's say?
But my the master student in my laboratory taught me the way to do environmental DNA analysis, and also there is a manual, the how to do water sampling and the DNA extraction and PCL. So it is hard to get used to it, but I go to the study area once 2 months.
Every 2 months.
Every 2 months. So I can get used to do the field survey from May this year, So I really enjoyed the water sampling and the filtration, and then I can, yeah, I really enjoy it.
Thank you.
Yes, thank you.
Someone else wants to comment or bring their own experience on the topic of learning the new techniques, let's say.
Can you guys hear me?
Yes, please.
Okay, so I just wanted to, it was a really good question that you asked, because usually when it comes to master's or PhD students, if we don't have a research group, or if the professor doesn't provide us with guidelines, or he doesn't really follow up with us, it is based mostly just on us it's like self-teaching. For me, in my case, as I presented the poster, I'm sure you guys are aware that my research involves two major different aspects of modeling or predictive analysis. So for me, like my thesis supervisor was very supportive in guiding me from the beginning of my master's, like what things that I needed to focus on and how to proceed with my thesis and the development of my results, how those results would be integrated into his artificial intelligence model. So, but it also did involve a lot of self-learning. Like, for example, my university only offered HECRAS courses during one semester, which was in the summer, and I didn't take summer. So I had to go to Udemy, I had to go to Harvard online school and try to find courses that were available that would give me the necessary information that I needed to develop my numerical model. And at the same time, as one of the researchers presented today, that getting the data for your numerical model, like detailed data, it's not an easy job. My own model involved getting hydrometric data from one source, bathymetric surveys from another source, terrain data from another source, and then climate meteorological data for his artificial intelligence model from another source. So it took a long time, but I feel like as researchers, it really helps us, because if everything is given to us, then it would just be like a course or like a certain aspect. But the beauty of research is that you get to find your own limitations and your own, like where you can go when you are putting your mind to something and then trying to get it to the end, even if you fail, but then standing up and doing it again until you can get the results that either you predict for, or like you put for yourself, or your thesis supervisor says. Just like to add that to your question.
Thank you. There are some question coming in the question and answer panel. The authors, the speakers, they can address there, or they can also reply live here. I don't. Yes, Mohammed, you want to answer your question live? Yes.
Yeah, sure. So Andreas asks, I have a general question towards methodology in terms of rising AI applications. Do AI applications speed up research in hydraulics as it may? So it depends on the type of AI model that we are using. There are a lot of different type of AI models, especially, and people think of them as a new field. But if you look at, well, during the research literature review of my paper, we found AI models that were developed in the 80s, right? So something starts from there, but with time, with the development of technology, we have seen a lot of developments and like fine tuning of these models. So for example, my model, it involved input of meteorological data that couldn't fit in one Excel sheet. So it had, I think, 140,000 rows of data over 10 columns, which were all fed into the model, and it just took like 12 minutes to give me the results. And the results from that model, based on like meteorological data, comparing them to my numerical model, they were pretty accurate. So then I was like, yeah, maybe I should be focusing more on artificial intelligence instead of numerical modeling. But at the same time, yes, it is very good, but it also depends on the user, how they are inputting the data, where they are getting their data, because it's all coding, it's all you can say, if you're using MATLAB, if you're using any of those techniques. So yes, it is much better, but it can give you results, but the value and like what we can say is like the value and their use could be very different depending upon what inputs you use or what approach you use, because it's all written by hand. I hope that answers the question.
Yes, thank you very much for the contribution. Again, the other speakers, they can also type their answer if they are not willing exactly to answer live, but it's nice to give also your comment on that. I think it's worth keep discussing also having your voice, the voice of other speakers, for this more open discussion regarding education and how to learn new technologies. I would say in the last 5 minutes also, Daniel, again, we will briefly introduce EcoINET and how we try to support early careers in their development. So I have two comments I would like to share with you regarding your presentations. General comments. I like them all. I think first comment is because of the format of this presentation, you were presenting basically one slide, and for 5 minutes, it's really a visual comment. If the poster is printed out, I think your poster were great, but when it's projected, the fonts and the graphic were kind of small. So if you want to be more catchy for this type of format, always remember to prepare your presentation according to the specific format you have to present with. So it would be visually more attractive and appealing if you had way less text and just way bigger graphic and plots and visualization. Because also in this short presentation, it was really hard to read, and the purpose is not to read what you wrote, but to listen to you. You had a very nice explanation of what you're doing. You can consider really for this type of format almost deleting all the text and having just some a nice graph or nice visualization. It will boost and boom your message, I would say.
And in general, I mean, it's a good comment that in sense it's in science there's the art also of storytelling, and so we have to tell a story that gets to the key points, and especially this kind of format, I always think it's like you're writing the story with a marker, so with very coarse pen you can't go into details, but of course you want to show graphics. I mean, that's the key. We always want to show the data, the results. So it's always the question, what do I need to show so that the audience can understand the key message, and what can I tell around that would give them the details and the background. And so I think in this step, this kind of format is a really great exercise to do that and to really think what's the key message that I'm sharing, because it's just 5 minutes. At other scientific conferences, you have double the time or so. So that makes it easier. So well done also on that as a first step. And I know the learning curve, and we've talked about that, like is steep in the beginning, and so it's great and takes a lot of courage also to do that. Yeah.
Yep. I have another comment, general comment again about the presentation. One thing I think it's really important to remember when showcasing your research is to underline and stress what are the implications, or if you want, why it matters. Some of you did very clearly, some of you less. It was it was reading between the line, let's say, the relevance. But it's always important to let the audience, especially in a very broad audience where not all the people are very into your topic or expert in your topic. So it's try to always think to the question why it matters, or so what about your research. If you can answer the question so what and explain, you are way more attractive in explaining your research, is another general comment. So we gave some comments to you. Now in the next, well, let's say 5-10 minutes before again the final words from Daniel, would be nice to hear from you. What are your comments for IHR? And we were a bit discussing, I was proposing this question. So in terms of learning new technologies, education purposes or education offer of IHR, what do you have some comments for IHR? Would you like to see something more or something different from IHR, or do you have some expectations?
Hi. I wouldn't say this is too much of a, this is certainly a very small suggestion, but I had perhaps like the compatibility of multimedia within your slide. For example, I had a GIF that was supposed to play, but obviously the PDF format didn't accommodate for that. So it would be very cool if that was a possibility to include in the future, because I think some people may have even some kind of numerical model graphs that change over time if they made a video or something. Would be very nice to include for visualization purposes.
Yeah,
that's all. Yeah.
I would also have a small comment to the organizers and specifically the reviewers. Like when I submitted my abstract for review, I got it was a pretty broad comment from the reviewer itself. But when I submitted the revision, though, I didn't receive any comment. So it was like I got the feedback that he provided, and then he or she provided, and then I modified my abstract, and then I was just told, like, by this date you can submit your poster and your modified abstract, and then I just got a confirmation. I didn't know whether, like, the comments that they gave, because I modified it based on the comments, but I didn't just add everything, because there is some data that I have, some that I don't, right? And as you spoke about relevance, it's subjective from place to place. So as I mentioned in my poster, that we did have floods here. That's why we are doing this study, and et cetera, et cetera. So it would be better if I know you received like over 500 or whatever abstracts for this conference in itself, but by you hosting these events, you are expecting those numbers of people to submit and those abstracts to be reviewed, and then with a confirmation to be for the reviewer to just provide some more feedback, because when they request a revision, we work on it, and then to get feedback on that revision, maybe we did it perfectly or maybe we didn't do it perfectly, would be helpful for future like conferences, because it's my second year that I'm presenting in the Young Professionals Congress, and I didn't see it happening both conferences.
Okay. Thank you for the comment. I'm sure it will be took seriously, and we will try to improve the process. Of course, yes. Sometimes things are not always perfect, but I think there is the good willing from everyone. Other other comments, I was in general very happy to see the very wide distribution from contribution from different part of the wars and different countries, let's say, different applications, different case studies. It's very nice. It means also that the topic is broad and very interdisciplinary as I believe it is, since by its definition, talking about ecohydraulics, but in general fluvial hydraulics. If there are no other comments, I leave Daniel, the chair of EcoINET, give some words regarding our network, that it's in some way it's collaborating with IAHR, and then we can have the final greetings, let's say, or we can cheer and go on with the event. Daniel, I don't know if you can share the screen or yes.
Should be able to see the screen. So basically, Davide and I are here also on behalf of EcoINET. So we're talking about the early careers on ecohydraulics network. And so basically, I want to introduce you quickly what this is all about. Okay. Yeah. Okay. So basically, Early Careers Network was started about 10 years ago, not quite 10 years ago, at the International Symposium of Ecohydraulics. And the goal is basically to be a platform especially targeted to early careers researchers. So in a sense, the question that Davide posed was already kind of hinting on one of our goals, that we really want to focus also on supporting training, providing resources for early careers, and basically by that help to mitigate some of the key barriers that early careers might face in their careers. So in the sense, we are a supportive network. We have a platform where we do communication dissemination through different channels. I'll talk about that more in a second. We organize and support target events. So for example, one event that we support has been the Young Professionals Network Congress, but also was at the International Symposium of Ecohydraulics. For example, we have workshops, pre-conference workshops targeted at eco-careers, early careers, that really help us to get together and present, form a community. And then basically we present engagement and impacts on ecohydraulics. And in overall, basically our commitment is, through this network, we want to promote diversity and strengthen the interdisciplinarity in ecohydraulics. So basically we have a committee that is organizing different activities. And here I just want to show you the faces of the current committee members. So we're basically spread throughout the globe from different, in the sense, backgrounds in ecohydraulics, from engineering to ecology. We're sitting in Europe, Australia, and so on. Basically, each of us has taken up different roles in the network. We basically have different points, things we do. So we, as mentioned, we participate in conferences, we do different outreach activities and various strategic actions. And a lot of that is done online, also just because early careers are distributed everywhere. And that's just a way of how to connect people. So we have in our members list, we have over 200 enrolled members from 30 countries. And you see here that we're spread across the globe. We're quite active in social media. This icon needs to be updated. We're at X, we have over 600 followers, and on LinkedIn page, 550. We post, what do we do here? I'll give you some examples. So we really like to encourage social media member stories. So in the sense, if you have a new paper, we really encourage you to tag us. We want to amplify that and basically showcase to the eco-hydraulics community what is done by early careers. Also, when we're on conferences, basically we use social media to showcase cool presentations that early careers are doing. Then there's also the opportunity to share more detailed stories. Like, for example, we have here in the past had some member stories of river safety courses, or another member posting a post on basically big rivers in Africa as part of her research. And then basically it's different webinars we're helping to do. Join. Here's also young professionals event we joined back in Granada some years ago, and basically promoting, for example, IAHR things. So in that case, we're linked together. Also, recently we've started a YouTube channel, basically to, on the one hand, we have some video interview series to, for example, we have videos on there on how to win a Marie Curie grant, talking with a colleague who won one, or with another colleague on career paths outside of academia. And in this regard, we want to encourage you also to, if you say you have a story you want to share, you want us to interview you, get in touch with us, and we'd be happy to set something up for the future. And in this regard, my final slide, I encourage you to follow us and join us. So by scanning this QR code here, you're linked, you get to the enrollment form. So we have around 4 or 5 times a year newsletter with a lot of updates on conferences and other things going on in the community. We're active on social media, also posting a lot of job posts from around the world. So I think we have at least two job posts per week or so, because there's just a lot of coming in, people forward things to us, and we use the channels to spread. And of course, if you want to get active and start help us build the community, there's the possibility of that too. And you can contact Davide or myself, or contact us through our channels and get in touch. So with that, thank you very much, and we can wrap up our session. Yeah.
Thank you, Daniel. Thank you again to all the participants. I think it was a very informative and very interesting session. I thanks again the organizer, Manish Pandey and Arianna Varani, for hosting, and all the organizer in the background that are not here from IAHR. I think we are perfectly on time to pass the ball for the next session on fluid mechanics and ice research and engineering and hydraulic machinery. Oh, it's a long one. Hydraulic machinery and system. Okay, and enjoy the day. It was nice to see you here. Enjoy the second half of the event, and hope to see you around in person somewhere at some conferences. Thank you very much.
Thank you, everyone. Take care.
Thank you.
Have a good day.
Thank you, one and all.
Thank you.
Thank you.
Thank you.
Okay, great. So thank you very much, Davide and Daniel, and all the previous speakers from the previous session for this very interesting session, and also for the additional information provided on EcoNet that I'm sure that our participants will find it very interesting, especially because it's a very dynamic association supported by very dynamic members. So. My name is David Ferras, and together with Manish Pandey, my colleague from the organizing committee, we'll be chairing the next session titled Fluid Mechanics, Ice Research and Hydraulic Machinery. It's my pleasure to introduce also the chairs of this session. On the one side, we have Tomasz Kolensky from Gdańsk University of Technology from Poland, and Claudia Dusse from Roma Tre University from Italy. Before passing the word to them, I would like to remind some few rules. So we have 7 speakers ahead. Every presentation shouldn't last more than 5 minutes. And by the end of these presentations, there will be a Q&A session between the speakers and the chairs. And in the meantime, if anyone from the participants, if you have any questions, I invite you to use anytime the Q&A chat box. Said that, I would like now to pass the floor to the chairs of this session. So Claudia and Tomas, the floor is on yours. Is on your side. Thank you very much.
Maybe I should give the voice to Claudia first, but I think it doesn't matter too much. I'm very happy to be here as the chair of the session. Quite unfortunate there is no any research related to ice research and engineering. I'm the chair of this technical committee. Possibly because we have the symposium in summer, so that maybe make that people present everything during the symposium. Probably too short time for that. So I'll be happy to chair the session together with Claudia. Maybe Claudia, you want to say a few words?
Yes, thank you. Thank you, David, for the introduction. And I'm Claudia Duce, and I am the chair of Fluid Mechanics Committee. And the Fluid Mechanics Committee focuses on both basics and applied environmental fluid mechanics with application to hydraulics research. And I would like to highlight that next year, in 2025, we will organize one of the conferences under the umbrella of the Mechanics Committee, that is the Shallow Flow Conference that will be held in Turin in September. Yeah, that's it. And then we can go ahead with the presentations and posters.
Yes. So we have a first presentation, application of algebra, wall modeled LES approach for simulation of jet pumps, which I'm not sure because there are three authors who will be presenting, probably Akbar or Jay or Sebastian.
Hello.
All right, so floor is yours, Akbar.
Okay. Hello, everyone. Thank you for this opportunity. My name is Akbar, and I'm a PhD student in University of Sherbrooke, Canada, under the supervision of Professor Lacey and Professor Olsen. The title of my presentation is Application of Algebraic Wall Model LES for Simulation of the Internal Flow of the Jet. I'm going to start by briefly explaining what jet pumps are first. You can think of the jet pump as a regular pump, such as a centrifugal pump, but without any moving parts. These are passive pumping devices which operate based on the energy of a primary fluid instead of any electrical or mechanical energy. They are also called inductor or ejector. Jet pumps have been employed in various applications such as mixing and transportation of hazardous fluids because of their simplicity and reliability. Our study focuses on understanding the complex flow behavior inside the jet pump using computational fluid dynamics. To address the turbulence phenomenon, we employed the algebraic wall model LES approach. Figure 1 shows a 3D view of the jet pump pre-simulated along with its cross-section. As you can see, the primary flow enters from the red area and is discharged into the mixing throat via a nozzle. This process creates suction, pulling in the secondary flow through the blue area. I should mention that water is used for both the primary and secondary flow, and the volume flow rate of the primary flow is around 4 liters per second here in this simulation. Figure 2a shows the coherent structures using Q criterion, which are colored by velocity magnitude. It's clear that ring-type coherent structures form around the primary jet, and their diameter gets larger along the flow direction. The contour of the instantaneous velocity in figure 2b also shows the shear layer growth between the primary and secondary flows The figure also shows that the dissipation of the jet core at the beginning of the diffuser. So you don't see any jet core once the flow gets into the diffuser. In figure 3, I extracted the streamwise velocity contours at various cross sections in the mixing throat and diffuser. The figure clearly shows that the asymmetrical behavior of the flow inside the jet pump. Finally, figure 4 demonstrates the validation of our CFD model. Here, the total pressure at two cross sections and the static pressure on the wall of the jet pump are compared against the experimental data. As you can see, the trend is correctly predicted and the quantitative results agree reasonably with the experimental data. All in all, it can be concluded that the selected numerical approach has considerable potential for capturing the unsteady dynamics within the jet. At the end, I want to thank the NSERC Chair on Industrial Efficiency in the University of Sherbrooke for funding this project and Research Alliance of Canada for providing HPC facilities used for running the simulation. I appreciate your attention and I'd be happy to answer your questions.
Thank you so much for being quite informative about the study. I'm not sure if we have time for question now or rather in the coffee break.
Questions are in the coffee break.
Yeah, that's
We
what
should
my
go
note
ahead
showed.
now. Yeah.
So we just go ahead for the next present. Yeah.
Hello.
So yeah. So the next one will be assessment of DFSAM for providing turbulent inflow boundary condition to large eddy simulation T-shaped open channel confluence. And I see Alemo is already here, so please go ahead.
Okay, hello, my name is Alemo. I'm a PhD student at Civil Engineering Department, Ghent University, Belgium. My presentation focuses on the assessments of the FSM for providing turbulent inflow boundary condition to a large ED simulation of a T-shaped open channel confluence. Confluences of open channel present in fluvial networks and artificial channels. And a confluence hydrodynamics is complex and usually studied in a schematized geometry. Nowadays, it's common to use large ED simulation to study detailed analysis of turbulent flows. For this study, I have chosen DFSM, that is a divergent-free synthetic ED model method that basically generates a turbulence by advecting a number of EDs with a specific shape and random intensities. And there are several parameters that should be set for a DFSM, but the most important parameters are characteristics length scale, integral length scale, and the input variable is Reynolds stresses. The objective of this study is to verify to which extent the value of Reynolds stress imposed at the inflow influences the characteristics of the flow upstream and downstream of the branch. I used OpenForm tool to simulate my model, and an experimental data from a dataset of Weber 2000 was used with a discharge ratio of 0.58 and with a downstream velocity of 0.604 meter per second and the tailwater depth of 0.308 meter. And the input parameters for the FSM were the characteristics length is assumed to be equivalent to boundary layer thickness, where for the integral length scale, I took 2 times of the boundary layer thickness. And for the Reynolds stresses, it is assumed as isotropic turbulence. The isotropic turbulence was assumed to calculate the Reynolds stresses. 4 different turbulence intensities were chosen: 0, 5, 10, and 30% to compute a Reynolds stress, and that can be used as input value in the inflow boundary condition. And as you can see from the figure, the primary and the secondary flow velocities and the turbulent kinetic energy have not changed that much, even though we try to use different turbulence intensity, which changes the Reynolds stresses. As a conclusion, the selected turbulence intensity when specifying the normal Reynolds stress as a inlet for the FSM has a small influence downstream of the confluence because the flow is dominated by shear layers originated from sharp edges. Thank you.
Yeah, thank you so much for a nice presentation. And we're gonna go ahead, move to the next presentation, full developed open channel flow over the high density muscle bed, partly buried in the gravel bottom. I think Tommaso, it's presenting. Yes, you're already here.
Yeah.
We
Can you hear me?
each other? Very good.
Yeah.
Go ahead.
Okay. Thank you. I'm Tommaso Lazzarin from the University of Padova. The present work describes the fully developed open channel flow over an array of freshwater mussels partially buried in a gravel bed. Freshwater mussels are crucial ecosystem organisms in rivers, and for example, they contribute to water filtration and bed stability, but also they provide habitat for the species and many other things. However, they are endangered species threatened by the changing climate conditions, and so it is important to understand hydrodynamics around these mussels to preserve their survival. However, previous numerical investigations rely on individual mussels, but typically these mussels are grouped into clusters that are called mussel beds, and for the reason, the present study consider the flow over a high density mussel bed and describe this flow in terms of velocity and turbulence. The numerical simulation are conducted within Statistician Plus computational suite. The model uses the digital reproductions of the surface of a gravel bed and of the shape of real shells that have been enriched with additional parts to account for incurrent and excurrent siphons. And the shell shape is then replicated until, within the bed until reaching a density of 300 mussel per square meter. And simulation are conducted with the DES approach for turbulence and also with periodic boundary conditions in the longitudinal direction to simulate an open channel, fully developed open channel flow. So in case of a mussel beds, the interactions between the various shells becomes significant because of the proximity of the mussels with each other, and so the local flow field is influenced by the presence of neighboring mussels. For example, the figure number 2 illustrates that how streamwise velocity is influenced by these different mussels, especially for the first group, while you can see that the mussel located downstream is less influenced by the presence of other mussels. This figure also shows that there is a reduction of the streamwise velocity in the bottom layer. And to quantify this reduction, we compute the double average velocity to reduce the complex three-dimensional flow into a single profile. And by comparing the profile of a simulation with only the gravels and a simulation with gravels and mussels, we quantify how this reduction was significant. Also, the presence of mussel shells induce strong peaks of turbulence kinetic energy. they remain visible also when muscles are clustered. However, we observe that the TKE at the back of the shells are typically more influenced by the presence of neighboring muscles, again, as in the case of the first group of muscles, while the TKE peaks that arise at the top of the shells are less influenced by the presence of muscles. Even in this case, we computed double average profiles of TKE. In case of the graves that correspond to the dashed line, there is only a single peak just above the graves. However, when in the simulation with muscle, there are two peaks of TKE, one induced by the gravels and a second one that locates at the top of the shells and that is dominant is also observed. So at the end, the study allowed to evaluate the impact of muscle beds on mean velocity and on the turbulence in case of for fully developed flow over gravels. Besides observing the reduction of velocity and increase of TKE, we also double averaged these variables. So we were able to quantify this effect. Specifically, we measured the reduction of the streamwise velocity in the lower layer of the channel, and also we observed that in presence of high density muscle beds, there is a second peak of TKE that arise at the top of the shells and that becomes dominant in such conditions. So that's all. Thank you very much.
Yeah, thank you so much. That was very interesting. And we move to the next presentation. I just try to find it. It's hydraulic check of overflow structure in sanitation network using hydraulic simulation software. And Luis Kaya, it's presenting. Yeah. So please explain the complexity of that work.
Okay. Good morning to everyone. I am Luis Caja, engineer from Hydrants. And today I want to talk about our innovative approach that the main goal is to determine the behavior of this type of infrastructure, mainly the spillways in the sanitation network, during an episode of rainfall using simulation software. It is important to know that this type of discharge that caused by the overflow in these spillways can produce a hard impact on the environment in different types, such as rivers, in some cases. So with this method, we have studied the different spillways using different software such as IAHR, which is a 2D tool, and also ANSYS, there is a CFD tool. And with both, we have developed the models and the different elements of the internal elements of the infrastructure of the spillways. With that, as you know, we have to follow different steps to obtain the model with the software, such as the introduction, the creation of the geometry. Important to introduce the different internal elements, and after that, of course, the boundary condition and of course the mesh. With that, we obtain the results, and in this case, the main result that we want to obtain is to determine the water level that will be affected of the inflow rate that is introduced to this type of infrastructures. So with this, we have developed different models, and we have determined the water level in different points of one example of one infrastructure of the water level. So with that, we can define in which time or when the overflow of the discharge will happen, and which will the inflow that will cause the overflow. So as we can see in the graphic number 4, we can see that depending on the inflow rate, that is on the horizontal axis. We can determine the water level that we can check it in the left side. So when the water level exceeds the weight level, that is the limit that it should not be exceed, the overflow will happen. So with that, we can define the relief flow and determine mainly the impact that will happen in the environment. So with this, we have a good prediction tool that can help us to determine which will the limit of the inflow that this type of infrastructures can accept. And furthermore, it can be also useful to determine which modifications is needed to do inside of the infrastructure to improve the behavior or the quantity that water that can accept. So with that, it also can be helpful to determine the flow range that, as I commented before, these spillways can accept. So as a conclusion, we can say that the mix between the simulation software and of course the experimental data that has been obtained with different sensors and visits to this type of infrastructure could produce in a good mix to obtain a good tool to create a powerful and cost-effective tool to determine the behavior and the capacities of the spillways. And today, nowadays, the cities facing different challenges to fight the climate change. And with that, we can help in one of them, trying to reduce the impact in the environment. That's all, and thanks for your attention.
Thank you. And I would like to encourage the attendees to write the questions in the question and answers box that is in Zoom. And we can go ahead with the next presentation that is numerical modeling of sediment transport and incipient motion in crosswise trenches, assessing geomorphological changes. Is one of the other.
Yes.
Yes.
Hello and good afternoon, everyone. My name is Zahra Sanovari and I'm a master student in civil engineering, specializing in coastal engineering and marine structures. From American University of Technology, Tehran, Iran. And today I want to share with you my initial phase of research in sediment transport and incipient motion, which is titled Numerical Modeling of Sediment Transport and Incipient Motion in Crosswise Trenches, Assessing Geomorphological Changes. Sediment transport leads to erosion, deposition, and changes in morphology, and accurately understanding when sediment starts to move, which is called incipient motion, is critical as it directly impacts the total load of transported sediment and bed level changes. To address these various criteria have been proposed in the literature by many researchers. My study examines how these different formulas of incipient motion influence the modeling of sediment transport. At this early stage of my study, I simulated a channel with a crosswise trench, a trench which is excavated perpendicular to the flow, and using the 3D software focusing on the siltation process. Figure 1, as you can see, illustrates this trench and the dimensions of it, as well as the locations of measurement cross sections. I primarily applied the well-known Shields criterion formula for calculating the initiation of motion. and which the formula, as you can see, is critical dimensionless shear stress as a function of dimensionless particle diameter, which is a theta critical function of d star. And for results, my model's results closely matched the experimental data available in the literature, capturing the trend of morphological changes. For bed level elevation after 7.5 and 15 hours, for both, which is shown in figure 2A and B respectively, I achieved a very low root mean square error indicator, or RMSE, the value which the value is 0.01 meters. Also, for crosswise velocity and sediment concentration, in figure 3 only is shown for section 3. I achieved the values of root mean square error, which is average, of 0.06 meter per second for velocity, crosswise velocity, and 0.08 kilogram per cubic meter for sediment concentration. In conclusion, these findings confirm that the Shields criterion for initiation of motion is a reliable and robust model in sediment transport in aquatic environments. But as we move forward, I'm going to develop the DEF3D source code to incorporate alternative incipient motion formulas, aiming to identify the most reliable and the most accurate formula for calculating and computing the initiation of motion of sediment to accurately model the sediment transport processes. Thank you for your attention, and if you have any question, you can contact me via my correspondence email.
Thank you. Yeah, still I remember that question can be written in the chat, in the question and answers box.
Yes.
Yeah. And we can go ahead with the next presentation. Detection of incipient motion for non-buoyant plastics under wave motion. Is any author here? Yeah, thank you.
Okay. Good morning, everyone. I am Giulia Bonanno, a new PhD student from the University of Messina. The work I will show you today concern about the detection of the incipient motion for not buoyant plastics under wave motion. This research was funded by the PRIN 2022 project Platone on plastic transport due to waves and currents on emergent and submerged beaches. This project is divided into two parts, an experimental and a numerical part, but today we will focus on the experimental part that was carried out in the hydraulics laboratory of the University of Messina. The team is complex because there are not many authors on this topic in the literature. In fact, there are three reference authors. Goral et al. In 2023, Bajlager and Shatramp in 2017, and of course the Shields curve of 1936 for the study of incipient motion. The tests were carried out into a wave channel, and the 9 samples were tested into a 1 meter trial zone, in which there were 4 different bottom conditions: a fixed and smooth one, a fixed and rolled one, and choose and mobile bed with different grain size. For each sample, 50 particles were tested, and for generalizing the incident motion, a video camera was constantly recording the test in order to compare the movement of at least 50% of particles and the wave level in order to show what was the phase at which the movement was made. It was found to be triggered by the reaching the maximal orbital velocity. This velocity was used for evaluating the friction velocity according to Goral et al. For reaching the Reynolds number and the threshold parameter, in which the reference diameter was the area on volume ratio, but for our case of wave motion, it was not good fitting. In fact, we were using to consider the dn, so the nominal diameter of the single plastic particles, and the relative static friction coefficient by Lysenko in 1980, dependent on the grain size. So it was proposed a new adaptation of the Swift-Tal curve. In fact, in this way, as the present data, so the wave forcing and the current condition were good fitting. For any question, I am here. So thank you for your attention.
Thank you for your presentation. And we move to the last presentation, analysis of Salto Grande's power upgrade.
Hello, good morning. Good morning. Can you hear me?
Yes.
Good. Okay, so my name is Ignacio Teixeira. I am from Uruguay, a small country in South America between Brazil and Argentina. I work for a hydropower plant that's called Salto Grande. That means like big falls, something like that. And I will present a case of upgrade with repowering, the analysis of repowering the power plant. This power plant, it's a binational one. It's shared between the Uruguay and Argentina, but it works as a unique company. It divides the energy between both countries. It's originally it has 1900 megawatts. It has 14 Kaplan turbines of 135 megawatts each. And discussing with suppliers, we have been given the option of upgrading the power of each turbine from 135 to 150 megawatts. That would mean an 11% power increase and would be able to take the whole power plant to 2100 megawatts. So we have been analyzing if this would be convenient for the plant. The plant has been operating since 1979, so it has 45 years of operation with no upgrade. It's a plant of Soviet origin, the turbines and generators. So let's see what we have done to analyze this. First of all, we have used simulation software that is used by the local market administrator. It has been developed by the Uruguayan University, and it's widely used by the system administrator. It's called SIMSE. You have the website over there on the links. And we have done a 10-year simulation on the Uruguayan electric system with the power upgrade and without the power upgrade in order to see the impact and the differences. First of all, the first plots that we have there are how the expansion of the system would change in the case with power upgrade and without. For yellow, you have the solar expansion, and in blue, the wind energy expansion of the system. So you can see that in the last period, when you finish both cases end up with around 100 megawatts of expansion. But in the case of with power upgrade, we go more for wind, and in the case without power upgrade, we go more for solar. It's reasonable because solar, it's more aligned with the demand. The power of solar is more aligned with the demand. So when you are needing power, it's more probable to add solar. So that's the difference we have seen in the expansion. And then I think one of the most interesting results here is that by giving 11% power increase, you only get 1.5 energy increase in the end. As you can see in the plot over there, that shows the power increase in percentage over the years. The first years, the power increase is not so big because you are you are taking out of service the units to do the rehabilitation. But then when it ends, you get an average of 1.5%. And why is that big difference between the power increase and the energy increase? That's because you are increasing power, but you are not increasing river flow. So you will only be able to use that power when the flow exceeds the maximum flow you were able to use in the original condition. And the maximum flow the original power plant can work with, and without open the spillways, it's around has a probability density of around 80%. That's the plot you can see below the one of the increased generation. So basically that means that only in 20% of the time you will be above that flow, and you will be able to use that extra power. And that's the reason why it doesn't give you so much energy increase. So then we want to see the impact on the cost of supplying the demand for Uruguay and the investments needed. This power plant, it's state-owned. So when we did the business case, we really want to see how this impacts the whole business for the country, not just for the plant. So, and also the utility that does the energy distribution, it's state-owned. So it was really a state business. Then we found that the difference in the cost of supply and the demand for the whole country in that 10-year period, it's around $8 billion. And the difference is very small between one case and the other. It's probably within the uncertainty of these simulations. And if we compare it to the investment, it's 3 times bigger. So basically just by looking at these numbers, we see that there is no business case here because there would be no economic benefit. And also doing a power increase has risks for the power plant because as you are now applying better design tools than the ones that were used in the 70s, you are taking more risk. You are taking the design more to the edge. So, and there has been some cases where this has led to problems and early failure. So looking at the numbers are not good and you are adding risk, we think that this is not a good case for Salto Grande. But I can say that you have to do this analysis for each case. There are other power plants where other river flow probability density curves that are placed. The original ones are placed on a different point and that would be a different case. So this should be done for each power plant on each market. Thank you very much.
Yeah, thank you so much, all of you, for presenting. We've been encouraged to make it within 1 hour, so probably everyone take it very seriously, and we finish much earlier, which is good because we have more time to discussion. There were some questions. Now I see only one. I don't know, the other one disappeared. And the question comes from Professor Ahmed. And the question is to Zahra. What is the sediment transport model used and which parameter are used for the model calibration? So maybe Zahra, you can answer the question, please.
Yes. Can you please repeat the question one more time?
All right. So the question is in the question and answer. I don't know if you have access to that, so I will read it again. So what is the sediment transport model used and which parameters are used for the model calibration? So basically, what is the model for the sediment transport used in this Delft 3D and what parameter are calibrated?
If you mean the transport formula which is used in Delft 3D, the transport formula or model is used, which is for Van Rijn. I think the formula is 1983, if I'm not mistaken. And for calibration, actually, I used every parameter that I use as the input in the model is inside the experiment report from Van Rijn 1980, which I used in my reference list. But I used I done some calibration for the viscosity coefficient and diffusion coefficient, which is eddy diffusivity coefficient.
Thank you. And I don't know if you want to share. There is another question.
Okay.
It's for you, but varying as a reason formula in the 3D. Why did you not use the reason one? This is a question that you can read in the question and answers box.
Yes, there is a multiple formula in Delft 3D. You can specify which you want to use, but I used a default one, which is the formula proposed by Van Rijn in 1984, I think.
Thank you. And there are other questions that received answers. I think that it's good if we share it with the participants. And let's see. Zara answer this, and no, that's South Africa. There is one for Julia, and it's about critical shields parameters. It depends only on these stars or also other parameters such as Reynolds. Julia already answered, but we can share it with the participants, the answer.
Yes,
Julia,
okay.
yeah.
Okay.
Yeah.
Yes, the shield parameters depends on the hand, so the nominal diameter that that depend on the geometrical properties of the single particle. There are 3 dimensions, and when we have to we use the higher Horner volume ratio. One of these 3 dimensions go less, so we have to use something else like this nominal diameter that enters on the threshold parameters, but also in the Reynolds number. And another relevant parameter is the critical friction velocity. And in fact, for the shield curve, there is a steady current. Instead, in our study, we have wave motion. So the velocity is not constant in time. So we have to introduce some others coefficient, like for example, the friction coefficient, which depend on the dN and the grain size. So in this case, we have to use both.
Thank you. And I have a couple of questions for you, Julia, then if you can. I'm wondering, how did you select the duration of experiments during which you perform measurements? And the second question is about the characteristic of the plastics. If you use plastics with similar weights or different weights or shapes. Yeah.
Okay. The channel was 50 meters long, so we had to use a time for reproduce the wave, and then each test was 5 minutes in order to show if then 100 periods there was a movement because of the incident motion is the condition in which the particle do its first movement. So we if the 50% of particles were in movement, we stopped the test. Instead, if at least 5 minutes, 10 or 7 minutes from this time there wasn't any movement, we will introduce a new wave 8, increasing it. The 9 samples were all different for the CF, the Corey shape factor. In fact, there was a sphere, 2 cylinders, and 3 cubes with different density in order to compare if the same form, but the different density, but the same shape was doing the same incipient motion. And most of them were in PLA, so they were 3D printed, but two of them were PET, so the plastic bottle, and nylon from the tie cables. In this way, we have to introduce different materials, shape, and density. But at least, even if some of them have a dimension in the range of 5 millimeters, the last two were very, very stretched. In fact, they have the third dimension of 0.1 millimeter. In fact, we were into the zone of boundary layer.
Thank you.
Yeah, there are some questions. Seems like Zahra is the most popular one here. I think you should be happy with this. But the question was from Rafiu Jimo from Nigeria, who asked about other software. The other question you already answered, but he asked, I hope I didn't mix it. The person asked about the other software could be used for similar approach. So could you please comment on that?
Yes, it's very good that everyone has questions, but I know that there is in our team in university which are using a software called OpenFOAM, and it's hardly doing the signal transfer process, but they have used it and tried it and exported their data. But also other softwares, I think you can use Mike, I think it's doing signal transport, but I think the best one is Delft3D that you can use, which is straightforward, and you can use as many formula as you can. You can choose it, and you can so since it's open source, you can write your formula for initiation of motion, everything, and build the code.
Yeah.
Yes.
There is continuous question about collaboration as compared to other similar software. I guess related to this, what you have done to check in other software. Of course, you answer already that you believe that this is the proper one, which I agree. But maybe you can, I don't know, add some more to that.
Right now, I can't think of the more, since there are so many softwares, but I know it's, I'm at my initial phase of my research.
Yeah,
And
I guess that's the pretty much the answer. Basically, it's good to investigate a bit more, but you probably choose the proper software for that task. I guess your professor take care on that, and he or she knew what to do. If I could jump with my question, I didn't type it here, but I have a question to Akbar about the first presentation. The software was used, and my question was, because not sure if I understand it properly, but how I write it down, so I'm reading. So the simulation pressure profiles will be comparable to the experimental data. What basically the accuracy of this approach is, if you can discuss that.
Actually, the question is that how did I compare the pressure profile to the experimental data?
Sorry, I couldn't hear you well.
Can you hear me right now? Hello?
Yeah, I can hear you, but my question is if you compare the experimental data, your data with the experiments and how well they compared. Can you discuss that? Because you did that, but you can discuss in your opinion how well they are, because you just show it quantitatively, but if you discuss the quality of the comparison.
Yeah, so I wrote it in the abstract, the quantitative comparison. I can read it. For example, in one of the profiles, we have 29% of average percentage deviation, and the other one is 6%. And the comparison of the static pressure on the wall, if you can see the poster. So I have two comparisons. One is the total pressure inside the device, and the other one, the figure B, I guess, 4B, is the static pressure on the wall. So the static pressure on the wall, the comparison, the deviation is less than 10%, but the total pressure comparison in the first profile is 29%. And this is because near the wall, we have some challenges to capture the total pressure and velocity. Obviously, because near the wall, we have high Reynolds stresses, and the model that we use for representing the shear stress near the wall is challenging. So that's why we have high deviation near the wall, and that causes the high average deviation in that profile.
Okay, thank you so much. Okay, seems like there is no more question here.
I have a question.
Sure.
Yeah, I have a question for Tommaso.
Yes.
Tommaso, yes, please. I would like to have details on how did you measure the bottom because you used as boundary condition a real case in which you perform measurements of the gravel bed with muscles and you used this reproduction in the model. How did you measure it? If you can give some details.
Yes. Actually, we do not measure, but we take the surface from photogrammetry, and this photogrammetry was taken at the University of Palermo by the group of Professor Donatella Termini, and it was on a laboratory flume with gravels, and then they dry it, and then they scan with photogrammetry the surface of the deformed bed, and then they made a triangular mesh, and that was imported then into the three-dimensional code for our let's say for our tests.
Thank you. And I have also a question for the second presentation, Lemo.
Yes.
Yeah, I would like to know the model that you use is a commercial model, or is it what developed in the research group in which you are working?
Actually, it's open source software. Yeah.
And another question is, how did you select the turbulent intensities that you tested in your simulations?
Basically, I try to, I have only shown which is giving me some deviation near to my domain. That means, as you can see from the figure, for main channel and the tributary channel, for the upstream channel, for turbulence intensity of 0, we have almost 0, but for the turbulence intensity of 5% as a inlet, it becomes around 2, and for 10% it's around 4, and then for 30% it's around 6. So even though I used a much higher turbulence intensity at the inflow, which is an input for Reynolds stresses to compute the Reynolds stresses. It declines through my flow domain channel. So basically, I have tried by myself to see. I have started with like 0, 5, 10, 50, 20, and then I've noticed that even though I use equal interval, after 15%, the difference is not that much significant. So that's why I took 30% to see the extent of turbulence intensity in changing the Reynolds stresses. So basically, it's just a normal approach that is trying to figure out how the turbulence intensity could cause the turbulence inside our flow domain. So that's the way I choose turbulence intensity. If I answer your question physically.
Yes, thank you. And I have another question for Akbar.
Okay.
Yeah, thank you. It's about, you mentioned, Akbar, yeah, can you hear me? Yeah. You mentioned that there are coherent structures that are developing around the main jet. And my question is, did you just visualize this structure, or did you apply any method to evaluate the presence and intensity of these coherent structures?
I saw them with the Q criterion, but I'm not quite sure about intensity of the covariant structures. What kind of index can I use for quantifying the intensity of them?
Just if you apply any method to detect the presence of coherent structures, or just visualize any quantity to see it. It's only a visualization of
yeah. I use the Q criterion to visualize them. As I showed in the figure, we have some ring type structures when the primary flow and the secondary flow is not mixed together. So there's a ring that forms around the jet. But once the flow goes forward, these ring type structures are breaking apart. Yeah, that's the criteria that I use for visualizing them. In terms of quantifying them, I honestly don't know how to quantify them based on some index.
Okay, thank you.
Yeah, if I may ask also, because there is no more question coming, I had a question about this presentation by Tommaso. When you present the effect of this muscle and the boundary layer, or the rough bed which is affected by the muscles on the turbulence. You also discussed the issue about the average velocity movement. Is it in your opinion like important change if they are or not the muscles on the bottom, or the density of the muscle on the bottom has important effect? Because definitely has effect on the short layer, I mean close to the bottom. But what about the average velocity? You discussed this a bit. Can you evaluate a bit more?
Yes. Of course, you are right. You mentioned that the density, that is the number of muscle, affect affect the distribution of the velocity. In our simulation, we make also other simulation respect to the two I presented today. But all the simulation has been performed with the same mean velocity to allow comparisons among cases. But of course, when you increase the number of masses in a bed, you increase flow resistance, and so you affect also the potential mean velocity. In our experiment, the mean velocity was the same, and it was forced to be the same to see the effects of varying the mass density. But in a real channel, if you consider a higher density, of course, you will have a different velocity.
So do you observe, for example, increased water level maybe because of that?
No, because simulation has been performed with also a fixed, yes, with
everything was tried to be fixed. And the other following question from that, if the density of matter is high, I mean, increase to some level that this turbulence at the bottom is not quite visible and maybe it's treated as the layer. So is that the possible case that the turbulence will decrease?
Yes. Yes,
Yes.
we perform simulation also with very high density, and we observed that turbulence.
Okay.
Yes.
And if I allow one more short question, the software you use is the open source or is university software?
It is a commercial software.
Commercial software.
Yeah.
Okay. Okay, good. Thank you so much. Thank you so much for the discussion. I'm keep talking, so I will ask one more, maybe last question today to sorry, I forgot your name, but the last presentation about this Uruguay, that was Ignacio. Sorry for that. Basically, currently we're facing the increasing demand of electricity, which is quite common everywhere in the world. And is this approach when the institution try to increase the power of the electric power plant, it's to reflect this higher demand of the country, or there was some other just economic reason for discussing this issue?
The reason for discussing this issue is that we are on a rehabilitation project. We are planning the rehabilitation project because we have been operating for 45 years. So it's a good opportunity to do a power upgrade within the rehabilitation project. So that's basically what it has triggered the discussion. Yeah.
This is not related to some demands. It's more like there was a chance to make the project more efficient working.
Exactly. Yeah. The demand in Uruguay, it's well supplied right now, and we still have space to increase solar and wind power. So to expand the demand, we will keep adding solar and wind. That's
sure.
That's our conclusion.
That's the plan. Mm-hmm.
Yeah.
Mm-hmm. Thank you. Thank you. That was interesting. So I don't see any more general, I mean, the question, specific question to the presenters. I pretty much asked everything I wanted to ask. The other question was kind of repeated by other person, so I don't want to go any further. Maybe Claudia have something to add about the general question, the specific questions.
I already asked my questions. Yeah.
So I think we are in this so-called coffee break, which brings the opportunity to start some discussion maybe with all of you guys. We are shortly from now. Actually, now is the deadline for submitting abstracts for the World Congress, IAHR World Congress, which will go next year in Singapore. And of course, there are a number of issues related to that. And I would like to maybe start a discussion about this. What is commonly expected from this type of congress or conference or symposium? Why people like to attend and why you will possibly consider this symposium for going, or rather consider is just too much, too expensive. We don't want to go because that, let's say, is the waste of the money. We better spend the time on, I don't know, some other research opportunity. So basically discuss the pros and cons of the symposium and what is expected from your perspective from that type of large congress or maybe more local congresses, because we all trying to attend, trying to discuss with people, but maybe you have some good points related to that. Basically, open discussion here. If you like to share your comments, please. Okay, maybe then I start my thinking about. So, for example, this World Congress, it's the organized mostly in place, which has some obvious good part. So we see each other, we face each other, we can discuss by coffee or during the session. Some comments may come. It makes socializing and networking, and that may bring some good idea of the cooperation or research. So that's definite profit of going to conference and meet people. From the other side, the presentations. Is it any difference to be presented online or within the regular room in the session? Do you think you're more focused or more interested about the presentation which are presented in the room when you are exist, or when you are, or maybe it's actually more clear for you if it's presented through the computer screen and you can make more comfortable condition for you to make a notes and stuff. So it's of course related to the cost. For example, this one is completely free. So that's the very good example compared to quite expensive Congress, World Congress. So maybe that aspect could be somehow discussed here.
Hi, I believe it's quite different for the audience. The attention that is paid to the presentation when it's on site. It's you are there to pay attention to that. You are not distracted by or other things. And when you are assisting a congress online, you're probably on your computer answering emails, and so it's when you go there, you pay full attention. So it's quite my experience assisting congress. It's very different when you do it online or inside.
Yeah, true. I agree. Basically, we have more involved in that. We are not distracted. Like right now, you talk, somebody call me, and I need to send him message. I will call you later. In the conference, you're probably more focused on this, what people talking. So you may also remember from that, but at the online conference, but probably the memories will be a little bit more distracted, I would say. So that's fully true. And I also agree that the in-place conference is good. But then follow that, the in-person conference, what is the expectation? Do you expect it to be, let's say, low cost, but then related to that, the conference or site of the conference will be actually, let's say, not very professionally managed? I'm not asking specifically you, Ignacio, everyone here. So that's a have consequence. Of course, we can have some contribution from the local government or some other institution which may help organizing the conference, but from the other perspective, you will always face the situation like maybe the standard is not super high. Is it really expected from the scientific conference to be in high, let's say, high cost, but also high standard from that perspective, or is just for communication? So just simple rooms to contact each other. Maybe this could be somehow discussed. Yeah, I would say we just did the last year the symposium, and we try to make it low cost as much as possible. We try to consider that, of course, usually people cover the symposium from the project, from some research money, But if you try to make it low, it possibly will attract a bit more people to that. Of course, reasonable, so makes them happy with this what they're receiving. So we can go low, but we cannot go ridiculously low. I mean, to just very little money, let them just meet each other. I think that's not the best way. We still should collect some amount of money, reasonable, to cover the, let's say, food and all the important aspect of the conference. But I think we not should do it like luxurious, to not make this conference too much expensive to cover stuff which are not very important. And yeah, I don't know what his opinion. I'm just talking about that because that's recently discussed. Also is the issue of the how much money is in each country to the research. Some countries, even well developed, they are not very much supported by the government. The research is not very well supported by the government, and that makes so-called in IHR is usually distinguished between low-income, high-income country, right? This is good approach, I would say. Of course, I can discuss because why Poland is the high income country. We don't have too much money for research, but well, that's another story. From the other perspective, we should refer to something which will create the, let's say, possibility to come to the conference from the countries which are, let's say, not very high income, and then the money will be relatively higher for that approach. And then maybe it's also possibility to make the let's say how it's called hybrid conference, right? So you can still attend, but lower your cost to the minimum by only being let's say connected. However, this usually, as Ignacio said, they are not quite good interaction on the other side. Same with presentation online. If there is a in-place conference, they are, let's say, consider it a bit lower value, I would say. Yeah, maybe I'm talking too much about that.
I would just like to give you an insight from my point of view. Like probably when you are in Europe, the cost of the conference it's the most relevant one because you can get cheap flights to get to different places. For me, being in Uruguay, if I decide to go to a conference that is in Europe, the higher cost would be the flight tickets or over
Yes.
$1,000, and the conference cost wouldn't be that much. So just for you to keep that in mind when organizing, it's the situation here.
Yes,
Yeah, that's very
even if the same is true for our that from people from Europe that maybe had to move to USA or to Singapore, that of course the cost of the flights will be higher because, but so I think a compromise should be reached. So maybe some years, a year in one part of the world, and maybe the next
Yeah.
edition in another, maybe to meet the most to meet most the largest part of people, maybe in one edition or in another,
Yeah.
because maybe flight can be very expensive. Like I'm thinking to moving to USA or something like
Mhm.
that from people
Yeah.
from Europe.
Generally, IHR tried to move the conference to different regions of the world, especially World Congress. So the last one was in Europe, now is in Asia. But as far as I remember, there was also in South America. So this is somehow covered. Of course, this is difficult because the World Congress bring attention from any perspective. Any part of the world will be interested. And I'm not sure if it was ever in Africa, for example, right? So that makes or these regions of the world where where are, of course, large interest about the aspect of hydraulics or hydrology or whatever are related to water, but not many institutions or places to arrange the conference. Okay, there was also something like a question, what is expected? You are considered like a young professional people. From your perspective, what is expected about the IHR? What you find a good part? For example, this type of possibility, you reply positively to that because you want to be the part of this workshop or conference should be called rather. So do you find, for example, something which IHR were supposed to pay attention to make the institution more attractive to you guys as the young people joining the research community? And maybe there is something come to your mind.
I might comment as OC member. The idea for this is basically to ease the path of asking for money to your PI or whoever, because you don't need to. And you can just present what you did. And because like I'm in Poland as well, just to frame it. It might be that there is not always money available for PhD students or PhD candidates to go to a big conference. And in this way, we try to provide them with an opportunity, at least to show something. And then if the feedback is good, then they have a good point with the next request, let's say. And I think it's also easier to have people sharing sessions because I see that you could find the time for 1 hour for staying connected together with us and giving mentorship and guidance and feedback, which is always something that it's valuable because it's your time and like the time of people that put into the presentation. It's nice to see this exchange. It's very nice. And I'm like always, it's always a nice way to see the like possible new members, old members getting together, even if virtually. For the other things regarding costs, it's I think we don't discuss it anymore. It's like it's country dependent, so and funding dependent. There is, and it's time dependent as well. Like you might have money 1 year and the next year no money. So I think in maximum 3 minutes we need to close the session, or at least wrap it up for a real coffee or a real food.
Okay.
So that they have time to prepare the streaming, because we have a keynote coming. So stay connected if you want to follow the keynote. There is someone that raised their hands, but I think it's not yet. Please, if you want to ask a question, type it in the Q&A.
There's one comment from Q&A actually related to the financial aspect of that, and I fully agree with this, that even reduced cost makes still large challenges for the developing countries or researchers for developing countries to attend the conference. So I think this is still the issue, to maybe consider the lowering in general cost of the conference by reducing the necessary, let's say, what is the necessary part of the conference. Maybe we should consider actually to reduce it to some decent level, which will be affordable for the developing country people, or consider some special programs for reducing the cost or lowering the cost to this amount, which will be in relation to GDP of the specific country. But that's the large discussion related to that. Yeah. So I think we can slowly come to end, have the short break, real break, and thank you so much for sharing the research. That was great to talk to all of you. And yeah, I hope to see you again in some possibility, maybe in Rio Congress or some other place. And thank you so much again.
Thank you.
Thank you very
Thank
much.
you.
Pleasure.
Thank you, one and all. So, for
Thank
5
you.
minutes.
After a coffee break, welcome back to the fifth edition of the YB Congress. And today we have the pleasure to have the first keynote speaker of the Congress. Mina Rusgar is with us. As we anticipated yesterday in the opening Peace Congress, we featured two past winners of the JFK student paper competition. She won the first prize last year in Vienna, and she holds a PhD in civil engineering from the University of Manitoba, with a specialization in water resource engineering. And her research focus is mostly on ice affected channels and sediment transport. And today's presentation will be about the bedrock transport and the morphology in partially ice-covered channels. As for the technical session, please feel free to ask any question during the using the Q&A app, and we will address those questions at the end after Mina's presentation. Mina, the floor is yours. Thank you.
Hi. Good afternoon, everyone. I'm really happy to have this opportunity to talk about my research. I just want to make sure that you can hear me perfect. Yeah. Okay. Yes, I should share my... Yeah, can you?
Yeah, it's perfect.
Yeah. Okay. Good afternoon, everyone. I'm going to talk about my research into ICL and experimental study of bedrock transport and bed morphology in partially ice-covered channels. I will go through a brief introduction, then I will talk about the methodology, and then I will talk about the result and discussion for this research. You know, border ice is a type of ice that most of the time it takes place in a place along the river in a place that we have shallower water and also low velocity. The way that border ice takes place is that the central portion of the river remain open, and you can see a few pictures of border ice in this slide. And when we have border ice, the coexistence of ice and open channel flow can make some complexity in the analysis of turbulence flow. That's why it can be significant research. Also, when it comes to sediment transport, in cold climate, the interplay between sediment dynamics and ice cover plays a important role in changing the riverbed. And you know that in cold climate, we can experience, or river reaches experience border ice for a long portion of the year. It can happen during both freeze-up time and also breakup season. And you know, although this is an important subject, the research on this subject is not that much. That's why we decided to focus on the effect of border ice on sediment transport. As I mentioned, the presence of border ice can cause redistribution in velocity profile. And here in this slide, you can see the velocity profile of previous study for open channel flow, fully ice covered and partially ice covered flow. And here you can see just half of channel due to symmetry. And if we just focus on the partially ice covered flow, we can see that we have three different regions. One region is the side section, which is mainly similar to fully ice covered flow. The open section, or the center one, is really close to open channel flow. And then we have a transition zone here, which is influenced by both open section and covered section. That makes the complexity. And also when it comes to core secondary currents, again, we have a similar thing. When we have just core secondary profile for open channel flow, we have two corner secondary currents in the side of the channels. But when we have border ice, we have core secondary circulation, two main core secondary circulation at the edge of the border ice, which is resulted from streamwise vortices, and these core secondary can cause some effect and on bed load and also bed morphology, especially in the age of the border ice. I will just do a little review and background that for some parameters that we need to know for this study. We know that when we have a uniform flow, we can use this equation to calculate the average shear stress. And then according to previous study, if we want to calculate bed shear stress, we can multiply average shear stress by a coefficient of 1.2. And again, here we can see the definition of shear velocity. These parameters are using in this research a lot. To continue our introduction, I should mention that the initiation motion of the sediment occurs when the exerted shear stress exceeds the sediment threshold. And then this movement is typically categorized in 3 different groups. And this group can be different considering this ratio that is defined here. And this ratio shows the fall velocity over shear velocity. In our study, this ratio, the range of this ratio was from 2 to 6. That's why the main focus of our research was on bed load. And when it comes to bed load, one parameter which is very important is bed load transport rate, volumetric bed load transport rate, which can be easily calculated by dividing the volume of dried sediment over the time of the experiment. Again, when the sediment particles start moving, first, if we just consider flat bed at first, the start of moving, then they have some unpredictable erosion and sedimentation that this cause a pattern that it has a slight disturbance in the bed surface elevation, and we call this a slight change in the surface of the bed form. So when it comes to bed form, there are 2 main parameters which is very important. One of them is length of the bed form, and one of them is height of bed form. There are lots of sediment transport equation that use these parameters in their equations, and also the relation of length and height of the bed form are important in the literature. So with this brief introduction, it just brings us to the objective of this research. First objective of this research was just exploring the influence of border ice on bed load transport rate and also bed load transport distribution in a channel width. And also we want to see if we have asymmetric border ice, how can asymmetric border ice affect the bed load transport rate and distribution. And also we investigate the effect of both symmetric and asymmetric border ice on bed form characteristic. To be able to do those research objectives, we designed few experiments and with different parameters. The first parameters which was important in our study was flow strength, and flow strength is mainly, dimensionless shears, bed load shear stress, which can be calculated by this equation, and we have 5 different shear flow strength in our study. The next parameters was coverage ratio, and coverage ratio is the ratio of top width of the channel, which is covered by ice, over the top width of the channel completely. So again, we had 5 different coverage ratio in our experiment. And the next parameter that we investigate was level of asymmetry. And by level of asymmetry, we mean that border ice width in left-hand side and right-hand side of the channel was different in different experiments. So in this slide, you can see the experimental setup and the schematic of the flume that we use in our lab in University of Manitoba. Here you can see that the flow is coming to headwater tank, and then after that coming to our flume where we have the sediment and we are simulating the sediment. And then at the end of the flume, we have sediment trap. That's the location that we are collecting the sediment and then dry and weight them. And also because we did the investigation on bed form, we had a location that we had our photogrammetry analysis, and then we took a picture in this location, and we wanted this location to be far enough from the inlet of the channel. We use this device to make the flume flat before each experiment, and because we want to have it repetitive and just also have a desired slope for all our experiment. And here again, you can see the sediment trap. We use bubble wrap to simulate ice, and in this picture, you can see fully ice covered, symmetric partially ice covered, and asymmetric partially ice covered flow. And regarding the experimental procedure, I should say that we just did few steps for all the experiments before all the experiment. The first step was for sure flattening the bed to the desired slope, and then we tried to have a uniform flow by adjusting the tailgate, and then experiment was run for the required time. And then at the end of each experiment, sand in the sediment trap was collected, dried, cooled, and weighed. And then we used those equations that I already mentioned to calculate the volumetric sediment transport rate. And then after each experiment, water was slowly drained from the flume, and we took photos for our photogrammetry analysis, and just considering the optimal procedure. By optimal procedure, I meant that, according to AGSoft, we need to have enough overlap, which is when we are flying alongside the flume, we need 80% of overlap, and then we need 60% of side overlap when we are taking pictures. So at the end, we had 40 or 50 photos for each experiment. And then after that, 3D dimensional point cloud and digital elevation model were created from each set of experiments just using AGSoft software. Going to our result and analysis, I should mention that our result is mainly in two different categories. First one, bed load transport rate, and the next one is bed form. So when it comes to bed load transport rate, first I'm talking about cross-sectional average result, and then I'm talking about the distribution of bed load transport rate in channel width. To be able to understand the analysis of our result, again, we need to know a few parameters, dimensionless flow strength that I already talked about it, and dimensionless bed load transport rate. To be able to calculate the dimensionless flow strength, one parameter which is important and we need to consider it for different condition is how to calculate hydraulic radius. And for that, we need to know the area that we are using and wetted perimeter for each cases, which is shown here in this picture for all the cases that I had in my experiment. And then it comes to dimensionless bed load transport rate. And for that, we already calculated the volumetric bed load transport rate, and we need to just make it dimensionless. As I mentioned, there are lots of equations in literature that related the bed load transport rate to flow strength. And for example, in 1991, you can see this equation. And then in 2015, Nack and Shen tried to compile lots of studies, lots of data about open channel flow and also fully ice covered flow and then find out the coefficient for this equation. But the thing about their equation was they didn't consider partially ice-covered flow. That's why we tried to, we did the same calculation for all of our experiment, and then we calculate the theta and phi, and in this we plot our data on the graph that was suggested by them here. And you can see that the x-axis here shows the flow strength theta, and the y-axis shows the dimensionless bed load transport rate, or phi. And our data, considering open channel flow, fully covered, and asymmetric and symmetric border ice, they all were in a good match with the previous study. And we also try to have a best fit for our data and suggested a coefficient which was related to our data as well. In this slide, I'm going to mention that when we have a constant discharge and then this border ice width increase, how it can affect the bed load transport rate, or and how we can see the effect there. We know that when the border ice width increase, then we have more resistance, and then it can cause the more water depth, and then the flow strength decrease, and then the dimensionless bed load transport rate decrease too. And then, so this result is shown in our result as well. So now I'm going to move on to bed load transport distribution. To be able to talk about bed load transport distribution, we define a coefficient here. This coefficient is mainly talk about the ratio of bed load transport rate in side section or covered section over the bed load transport rate in middle section. So if everything was completely uniform in the channel width, then this, because this width are all equal, so this ratio should be equal to 2. But we can see that in our result, even for open channel flow, this ratio is not 2, and that's because of the sidewall effect. But so we have sidewall effect for all of our experiment, and because that's something repetitive, again, we can say that we can compare the effect of border ice width for different, experiment. Here in this graph, you can see coverage ratio as a x-axis and this ratio as a y-axis. Something that is noticeable is that by increasing the coverage ratio, this ratio decrease, which means that when the coverage ratio increase, the relative sediment transport or bed load transport rate inside section decrease comparing to the middle section. And the other point which is noticeable is that this line is for the lowest flow strength, but when it comes to higher flow strength, we cannot see that much of a trend, which means that the effect of changing border ice for higher flow strength is not that much noticeable, and we can see the effect for lower flow strength much more obviously. Again, we have a similar water bed load transport rate distribution in channel width for different coverage ratio. Different colors shows different theta, and sorry, we have a same coverage ratio and same that you can see the picture here, and this shows the bed load transport rate distribution. Again, when it comes to the highest flow strength here, you can see that the difference of bed load transport rate in side section and open section, or open section and cover section, is not that much comparing to the lowest flow strength, that this value is almost 13 times of the value in side section. So it just confirmed the result that I talk about it here again. Here we want to talk about the effect of coverage ratio, and for that we have 4 different tests with the constant flow strength of theta is equal to 0.05. This one shows 2 tests of the symmetric one, and this one shows the asymmetric borderized test. And red line shows the coverage ratio of 50.5, and blue one shows the coverage ratio of 0.67. And also the bolded line shows the part of the section that is covered, and the dashed line shows the open part. Again, we can see that when the coverage ratio increase, so moving from red line to blue line, the effect of the difference of these bed load transport rate in side section and open section is more noticeable. In this slide, I'm going to talk about the effect of level of asymmetry. To be able to do that, we had 3 different tests, one of them for symmetric border eyes and 2 of them for asymmetric borders. One thing that is noticeable is that when we have asymmetric border eyes, the effect of border eyes on redistribution of the bed load transport rate is even more noticeable. And the other thing is this maximum value is moving to the center of open channel section. Although when we had the symmetric border eyes, we had the maximum value in the center of the channel. That was an interesting result. And then after that, I'm gonna just move to our resultant analysis for bed form characteristic. You know, after we did all the experiment, then and we had the output from AGSoft, then we had 15 different line, and we extract longitudinal profile in 15 different location of the channel width. And then for each of these longitudinal profile, we calculated the average height and average length. And then we plotted our data in the graph that was suggested by previous study here. And for example, in 1988, Fleming suggested an equation which relate dune length to dune height. And then in 2017, Bradley and Veneti again compiled lots of data for open channel flow and fully ice covered one. And then they just find out different ratio, and you can see the line that was suggested by them here. And we plotted our data, and we can see it's noticeable that our result is in a good match with the previous studies. And in this slide, again, we have similar graph, this time relation of dune length to flow depth and dune height to flow depth. And again, you can see that the green dots shows our result, which are in a good relationship with the previous studies. Okay, in this slide, I want to talk about again effect of level of asymmetry, but this time on bed form. And for that, I just brought up some 3D figures that it's about the bed form of each test. And so maybe it's more obvious in this kind of picture, and we can talk about it more easily. And one thing that is noticeable is that when we have border eyes, we have an offset of bed form from the flume wall. And this is influenced by level of asymmetry. For example, in the first case, when we have symmetric border eyes and the border eyes width in the right and left of the channel are equal, this offset is equal as well. But when it comes to asymmetric border eyes, this offset, the value become asymmetric as well. And then you can see that it is resulted from the border eyes width, and again here, same thing. And I should mention that all these tests has a theta equal to 0.07 and coverage ratio of 67. In this slide, I'm talking about the effect of flow strength. Again, for all of these tests, we have the same coverage ratio, C is equal to 0.67, and then we have different flow strength. You can see that for the lowest flow strength, we can even barely see any bed form. But when the flow strength increase, we can see the bed form, and also this initiation of bed form formation is noticeable, and the effect of border ice is noticeable. But something that is noticeable here when it comes to the highest flow strength, again, our bed form are mainly 3D and they had chaotic pattern, and you cannot see this initiation effect or the trend that we were talking about here. So it again confirms our result about bed load transport rate, that when we are talking about highest or higher flow strength, the effect of changing border ice is not that much noticeable. In this slide, I brought again a 3D format of the bed form here, and also bed load transport distribution in a channel width for the same case, and also bed form distribution for the same case. Again, you can see that all the results are compatible. And for example, here when we have less bed load or less bed movement in the side of section of the channel, then we have less bed form, and the height of the bed form is lower as well. So it's kind of the result of all the tests in one slide that we can see how comparable they are. So regarding the major research contribution, I should mention that this is the first time that we investigate the bed load transport rate and bed morphology in a condition like partially ice-covered channels, and then we try to see the suggested equation like NAC and Shen and see whether they are working for estimating bed load transport rate, and we saw that the results are good, but they cannot find out or capture redistribution effect that much. We also compared the bed load transport rate for a constant discharge, and we noticed the effect. And also we noticed that when we have the asymmetric border ice, again, it can cause significant redistribution, and it can change the maximum bed load transport rate towards the open section. And other equation that was suggested for characterizing the bed form are useful for open channel, for partially ice-covered flow as well. And then we thought that border ice, both symmetric and asymmetric one, can have effect in initiation point of the bed form, height of the bed form, distribution, and these effects are more noticeable at lower flow strength. This research contributed to 3 peer-reviewed publications that are that you can just go through them if you're interested, and also 3 conference papers. And for future work, it can be beneficial to expand the experimental scope and consider other parameters that can be important, like aspect ratio, bed roughness, and border ice roughness, and see how they can affect the bed load transport rate and bed morphology. And also one point is that we can just do the experiment for long-term study, but something that should be considered when it comes to longer study, we should make sure that we have supply from upstream of the flume. And we can use the result of this data for model validation, and then expand the numerical modeling and try to have a dynamic model can model the border ice growth and then see the thermal effect and other stuff that is not very possible to do in lab work. At the end, I would just like to thank you all for listening to me, and also my supervisor, Dr. Sean Clark, and the lab technician, Alexander Wall, for his help for the experimental setup, and also the funding of this project, and Serkan University of Manitoba.
Thank you very much for the nice presentation, Mina. I would like to remind to to the entire audience that you can pose your question using the Q&A app. And some questions are arriving, so we can start. Basically, in your experience, you have those sidewalls which might create problems. And what are your strategies to mitigate the effects of the sidewalls on the bed forms and bedload?
Sure. Yeah, as you mentioned, when it comes to lab experiment, for sure we're gonna have the sidewall effect, but we can, as I mentioned, because in our experiment, this sidewall effect was something that was repetitive. So again, we were able to compare the effect of changing border ice. So it was our experiment, but it's still good. But something that can be just make this sidewall effect less and less is that if we have larger aspect ratio or wider flume, then the width that we have sidewall effect is less noticeable, and then we can just delete that part, kind of thing. But this can be just done in maybe larger scale or with lower, with different aspect ratio, with lower water depth and this thing.
Still on the experimental approach, why did you decide to use bubble wrap to represent the ice and not other materials, for example?
This bubble wrap has some difference and some similarity to border ice. One thing that was, for example, about the roughness and the smooth border, because border ice is the type of ice that most of the time is the start when the start point of the ice, and that's why it's smoother. So about when we want to compare the roughness, border ice and bubble wrap are having similarity, but maybe it's not rigid, and border, when it comes to rigid, it's rigidity, then they are different. But because we had uniform flow, we didn't have that much problem, and we wanted to have our experiment for different water level that can give us the uniform flow condition. So we wanted something that is easily, we can move them, we can have different, for example, if I had 50 experiment, I wanted each of them for the, different water depth. And if we have fixed border ice, then we couldn't satisfy that. That was main, and we talk even previous study that was done, but not on sediment transport for the flow characteristic. They were using some solid thing like wood or glasses, but we saw that our results were comparable to them as well.
And how did you guarantee that the bubble wrap was attached to the water surface? It was just floating over the top?
Yes, it was floating over the top, yeah.
And yeah, one last part of this question, if you can reopen the presentation and go to slide 26 and give some more information on how you increase the flow strength, basically. And you created those different simulation.
Okay, you can see my slide now?
Now, yes.
Okay. Okay, the decision of about different flow strength, as I said, for each experiment, one important parameter for us was to have uniform flow. So we chose a range for our data that maybe it's better to talk about it here. First, one parameter that was important for us, border ice most of the time happen when we have lower velocity. It might happen in higher velocity as well, but the limited range that we wanted to consider, we wanted to just be applicable to real world as well. So we kind of decide about the range of flow strength that we want from here to here, and also the range of the bed load transport rate from here to here. That in this decision, lots of parameters, few parameters, I'm just trying to find a slide that here. For our range of data, lots of parameters were important for us. For example, when it comes to bed load range, the amount of sand that we could realistically collect in our flume was some parameters that limited our range, or the amount of time that we can have that much of sand was some parameter. And then when it comes to flow strength, again, we wanted to consider the velocity range that is important for us, or pump capacity. So we kind of decide about the range of flow strength that we want and the range of the bed load that we want, and then did some back calculation that, for example, I want to provide this flow strength for my experiment, and then I calculate U start, and then a bed shear stress and bed, and then discharge, and then it was some back calculation that then I could calculate the discharge and water depth that is needed in our research. I hope I answered the question.
Yeah. So basically, you say that you have some. Those experiments were done in relatively low flow conditions, because the high flow conditions don't play. They are not that common in the field.
Yeah, high flow condition, especially when it comes to border ice. When it's higher flow condition, it's mainly fully covered or open channel flow, but border ice most of the time with lower velocities.
And you see a different balance between erosion and sedimentation, depending on the flow conditions, in the maps that you showed before, also with the bed flow. So does any correlation between this imbalance and the hydraulic conditions that you impose? Did you observe any possible relationship between ratio erosion over deposition and flow conditions?
Something that I can just mention that, again, flow, when it comes to flow condition, again, it comes to flow strength, that is the important parameter. So when the flow strength was higher and when we saw the increase in flow strength, yeah, we had chaotic bed form, and then we had much more movement, and then this relation, I cannot or at least the scope of this in this research, we didn't talk about numerically relate them, but I can say that, yeah, by increasing the flow strength, this relation was just, the height was bigger and the bed form was bigger, and it was more three-dimensional and more, it doesn't have that much pattern, at least.
Okay, looking at those images that you showed in the last slide, 25, 26, that's kind of flattening of the bed towards downstream. I mean, the difference between eroded and deposited areas sounds to be reduced, if I got correctly what is represented in those maps.
I'm gonna just bring the slide, if that's okay. This one.
Yeah, this ones.
Okay.
So in the bottom, you have the upstream part of the flume, I guess, right?
This, yeah, this
Okay.
one.
So differences are, well, they sound to be reduced towards downstream. Is this what is reported here?
I'm not sure
I
that
see. I don't know.
I'm not sure that I'm getting your question.
Mhm.
You're comparing the upstream with downstream?
Yeah, exactly. In the same flow conditions, yeah.
Okay.
And the shape of the bed force, yeah.
Okay, yeah. We can say that yeah, that's something that it is noticeable that it become a little more maybe better pattern at the end. But honestly, I should say that I didn't compare it in a longitudinal aspect, and when it was about the bed form height and bed form width, we just used the average one. And maybe in this three-dimensional thing, you can see the exaggerated thing, but when it comes to average bed form height and length, it's not that much of a difference. So that's why we use the average height in longitudinal one. But we didn't compare, the width and the height in the longitudinal profile.
Thank you for the feedback. So you perform all those experiments with sand, right?
Yes.
Do you expect that changing the grain size might change your results?
Yes, for sure. Yeah, it can have lots of effect for sure. Even if we make it one reason that we consider this a sand first, when it's very smaller, I can again show. Oh, sorry. Here. For sure, changing the diameter and D50, even D50 is a parameter that is really important in our result as well. So, at first we started with a sand that was much smaller, and then we saw that, okay, it's not something that we can use. These are the preliminary studies. And then we wanted, according to our study, when it comes to dimension more than 1 millimeter, then the thermal effect is less noticeable as well. And thermal effect is not something that we consider in our study. So that was some boundary that we put for ourselves, that just have a bigger size than 1 millimeters. But for sure, if we have different distribution and our distribution was uniform, but it is some start point for this kind of study in border ice condition. So if we have a non-uniform one, or if we have different distribution, for sure it can make some change, because D50 is an important parameter in both bed load transport rate and this morphology.
Thank you very much. There's another question in the chat. Let's say, under the ice cover, sediment transport will be in a sheet flow rather than over the bed form. What are the condition of the flow under the ice cover and in the open channel?
Sorry, can you repeat your question?
Yeah, it's in the chat if you want to read it as well. So sediment transport under the ice cover is in sheet flow conditions or other conditions?
The flow condition is the same for the whole experiment. So when we have partially ice covered flow, so we have both ice covered one and then open channel flow at the same time. So the condition is just something in between, but when we just designed the test, it was the average, we wanted to have an average height of the flow uniform, and then these are the things that we desired for the average parameters. But then when it comes to distribution, some parts are covered one, some parts are open one, and it's just different.
Okay, and you analyze always bed load conditions, right?
Yeah.
You have always only bed load.
Yeah.
Yeah, I was wondering what do you see as practical application or implication of those kind of study?
Sure. As I mentioned, in some areas, especially in cold areas, that we can expect the border ice for long portion of the year. For example, lots of our design might be just based on the estimation of open channel flow or fully covered flow, and then we can say that that's the bed form that we expect. But now we saw that when the partially ice covered or border ice exists, it can cause some redistribution. For example, we can see much higher bed load transport at the edge of border ice. That can be maybe a design factor, and maybe if we know that this border ice is happening in some place like bridge pier, so then maybe our design based of open channel flow or covered one is underestimated or overestimated. So having a coefficient that related this distribution in a channel or in the stream is beneficial for practical work.
Thank you very much. And there is another question. Would the roughness of the experimental channel influence the distribution, the generation of the curves of the distribution or the behavior of the sediments? So what's the role of the roughness of the channel basically on all the processes that you described?
Yeah, okay. When it comes to roughness, we have ice roughness and also bed roughness. For ice roughness was constant in all the experiment. And for bed roughness, for sure, when the bed started happening, then we have the roughness is gonna increase as well. But to calculate the bed load transport rate, I try to, that's some decision factor for how long our experiment should be. So when it comes to higher flow strength, we just make the experiment shorter, and we wanted to see make this effect as low as we can. But I'm not gonna ignore that this can affect our result maybe, but it's not something that we consider. And the other thing that we try to consider, I was there and I try to maintain the uniform condition for the whole experiment. So although this roughness was changing, still we had the uniform condition. But if you want to be much more exact for sure, it can affect it. But in our calculation, we consider the composite manning that resulted from ice roughness and bed roughness, and we try to keep it constant in our experiment.
If there are no other questions from the Q&A and from the audience, I would like to thank you again. But before closing, I want to ask you if you would like to share some impression about your experience with JFK paper competition, because as we know, this Congress is also for young professionals. So if you have any insight that you want to share and how this would inspire them.
Yeah, for sure. Yeah, that was a really good experience for me because, in our research group in Canada, we always attend the IAHR on ice or CRIPE or, the conference that are mainly focused on ice. But because my work was included sediment as well, I just asked my supervisor whether I can attend that conference. And that was the first conference that we didn't attend as a group. We always attend as a group. And it was really good experience that I could be shortlisted in the general IAHR, although that I thought that maybe my work is more specific. And, I can say that I tried hard for that, but then it just improved my self-confidence, and I felt that, okay, I am ready for give presentation, and it teaches me a lot, and I gave lots of good feedback from judges of that experience. And then I'm saying that at the same time, it teaches me lots of stuff, and also improve my confidence and I believe about. And I really encourage people to have a experience of just attending conference. If they are a student, they can learn a lot about it. And if they are working, again, they can share their knowledge and they can just teach people or try to help other people to grow with each other. So this kind of conference and also having the opportunity to be rewarded is really good and beneficial for us, I guess.
Great. Thank you very much again for the presentation and for those last words. So in 10 minutes, we will start the next session on experimental method instrumentation, hydraulic structure. So we can have this 10-minute break for the speakers for the next session. Please raise your hands if you are among the attendees so we can promote you as panelists. And Mina, thank you again for the participation.
No problem. No problem.
See you.
Hi, Ariana.
I'm searching for people. Now we have 1.5 minutes before we start. And we missed 4 authors. So I will try to add them. We have the first 2, so we can start smoothly. But then we are missing number 3. I will keep you updated on whether we have anyone online. And yeah, I will just write again, please. If you're presenting in the upcoming session on experimental methods and instrumentations, and hydraulic structures, please raise your hands so that I can promote you as speaker. We have the third one, so I think we can go smoothly.
Good.
So Jose, are you sharing? And I am also one, right?
I'm gonna share my screen.
Yeah, just take your time. Okay, I think we can start. I would like to welcome everyone to this session, the first in the European afternoon on experimental methods and instrumentation and hydraulic structures. I would also like to thank my, let's say, co-host, Jose, for doing the hard job with me.
Thank you.
And I am welcoming now our chairs, Stefan Felder and Nadia Penna. And I think it's their time to lead the session. So just a few more things. If you have questions, type that in the Q&A. And please, for presenters, keep the microphone off when others are presenting. Thank you. Nadia, Stefan, floor is yours.
Yeah, thank you, Arianna. So welcome everybody to this session on experimental methods and instrumentation in hydraulic structures. So I'm Nadia Penna. I introduce first myself. I'm Nadia Penna. I'm a researcher at the University of Calabria in Italy. And my research activity is mainly based on the analysis of turbulence in open channel flows and also with vegetation. I'm also interested in interactions between turbulent flows and structures, and also on statistical characterization of bed surfaces and on sediment transport and deposition. So I ask also Stefan to introduce himself since he is the co-chair of this session, and then we can start with the first speakers. So Stefan.
Thank you, Nadia. Yeah, my name is Stefan Feder. I'm at UNSW Sydney in Australia. It's actually pretty early in the morning here, or midnight, just past midnight. I'm researcher in the space of hydraulic structures. I'm the current chair of the Hydraulic Structures Technical Committee. And this committee is addressing anything linked with hydraulic structures, be it structures in dams, spillways, but bridging out in all other areas of hydraulic structures as well, including looking at areas how we can improve these structures in context of sustainable development goals and highlighting the benefits of society while maintaining a balance between the impacts that these structures can have. All right, I want to pass back to Nadia, who will be doing the first part of this session.
Okay, thank you, Stefan. So we can start with the first presentation. The title of the presentation is Enhancement of X-Beach Model Performance with X-band radar data during flood events. So the speaker will be maybe Ivan.
Okay.
Okay.
Can I start it?
Yeah, you can start, please.
Okay. Thank you for the time. Let me introduce myself. My name is Ivan Aliatul Humam, a PhD student from the University of Tsukuba, Japan. And I would like to present my research on the title of Enhancement of X-Beach Model Performance with X-band radar data during flood events. This research was conducted under the supervision of Professor Satoshi Takewaka from the University of Tsukuba. So the background of this research is during the flood, large amount of sediment are transported from the river to the coast. However, in recent years, sediment supply has decreased in the Tenju River, leading to erosion along the nearby coastal area and river mouth. To address this issue, we work on improving the X-beach model to estimate the flow velocity and also morphodynamic during the flood, and understand hydromorphodynamic process in the river mouth. However, we lack of field data for validation of X-beach model, including flow velocity and morphological change. So the X-band radar have offer possibility to collect the data, since the conventional method is difficult to obtain the data during the flood. And I running the model for 1 week flood from 13 until 19 August 2021, which is the highest flood in the years. And you can see in the figure number 1, panel A, show our study site in the Tendu River mouth. This area is prone to flood from the river that cause erosion every years. And next, you can see figure number 1, panel B, show an X-band radar image. We can see the similarity between the satellite image in panel A and the X-band radar image in panel B. The white spot in panel B in the middle of the river represent floating object that can be tracked at 2-second interval to estimate their velocity using particle image velocimetry analysis. And X-band radar is crucial in this context for measurement because other instruments such as flow velocimeter, ADCP, action camera, or drone face significant challenge in collecting the data during extreme flood conditions. Next, in figure number 1, panel C, we can see the averaging of pixel intensity for X-band radar data up to 260 images that are collected for 1 hour's observations. We collect X-band radar data every 2 seconds, and by averaging the pixel for hourly observation, we can get the clear river configuration to assess morphological change. This method provides clear information about the surface coastal morphology, and the conventional method is difficult to obtain the morphological change. Using the echo sounder is struggle during the flood, and also satellite data are not available at the hourly frequency. And drone also have limitation under night condition. So X-band radar help fill the gaps in data collections. In this study, we estimate flow velocity and morphological change using the X-pitch model through trial and error process. And then we adjust the main sediment diameter setting in X-pitch to achieve result that closely match the X-band radar observation. Now refers to the figure number 2, panel A and B. This show the velocity distribution derived from X-band radar and X-pitch respectively. And to assess this accuracy, we compare the velocity distribution along the selected transect as seen in figure in panel C and D. The variation are relatively similar, which mean velocity from both methods reaching up to 2 meters per second. And moving to panel E, the average flow velocity over 1 week is shown. The X-band radar result denoted by the blue line and also the X-pitch in the black line. And between X-pitch and X-band radar, the flow velocity from 1 week flood is relatively similar. Following the variation of the water level difference from water level observation in the Tenru River and also tide level. And then we can move to the panel F and panel F and G. This is the morphological change result from X-pitch from pre-flood and post-flood. We can compare this panel with the panel in K and L. This is the observation of X-band radar. We can see a similarity, especially in the coastal area. We can see the sediment deposition from the X-pitch prediction and also the X-band radar observation. This is the qualitatively similar in shape. Especially you can see the semicircular bracteous ring in the coastal area. Next, for the morphological change, we also compare the river width widening at the selected river transect denoted by the green solid line in the panel K. The result is shown in panel G, the X-pitch and X-band radar compared in this figure. And we can see a relatively similar variation between X-pitch and X-band radar, especially in the river width widening. And then we also observe the erosion in the riverbed elevation as shown in figure H. We can see that the erosion is gradually increase, follow the increasing of river widening as observed in the X-pitch and X-band radar. And
Ivan, sorry, you may go to the conclusion.
Okay, in conclusion, we successfully enhanced the X-pitch model by optimizing the main sediment diameter setting through the trial and error, and the resulting of X-pitch simulation align well with the observation from the X-band radar. Thank you.
Thank you very much. So we can start with the second presentation. The title is Evaluating Measurement Techniques for Velocity in a Natural Channel, and the speaker should be Miguel Latorre. Right.
Yes, and then interrupts. Well, good afternoon to everyone, and thank you for the opportunity. Today, along with Denise, are going to present the poster evaluating measurement techniques for velocity and natural channel. Well, vegetation in natural channels shape flow dynamics, impacting velocity and sedimentation patterns, but also introduce challenge for traditional velocity measurement methods. This study compares a propeller-type grain-meter and the advanced Vectrino acoustic Doppler in a dynamic Pantanas de Villa nature reserve. By evaluating these tools in a complex vegetated environment, we identify the most reliable approach for accurate flow measurements, where conventional methods fall short. This comparison not only provides insights into the performance of these instruments, but also highlights their applicability in areas where these methods are face significant limitations. Regarding the methodology, as well as you can see, we work in a scenario where the channel is rectangular, with an approximate height of 0.87 meters and a transverse slope of 0.0044. The width of the channel ranges from 1.43 to 1.76 meter, while the depth varies between 0.1 to 0.33 meters. This depends on the section we are working on and the time of the year we are measuring. As for the measurements made, 3 cross sections were characterized. In each we measured 5 depths and 3 velocities with both the current meter and the Vectrino. In the case of the current meter, measurements were taken at 20, 40, 60, and 80% of the depth of the water column. And on the other hand, the Vectrino was submerged at the same depth for approximately 1 minute at each level.
Now, talking about the results, our analysis in June reveals that both the current meter and the Vectrino deliver highly consistent velocity measurements, differing by just 0.09 meters per second under identical conditions, as shown in the first table. This reliability is essential for building accurate numerical models. While the Vectrino's high sensitivity make it a powerful tool, it can be affected by sediment interference in high sedimentation environments, as shown in figures 2 to 4. Meanwhile, the current meter's performance depends on precise positioning to avoid interference, such as from vegetation or sedimentation. In conclusion, this study highlights the efficiency and reliability of both the current meter and the Vectrino for velocity measurements in natural channels, with minimal difference in their results, underscoring their relevance in equihydraulics. Accurate velocity data is essential for understanding flow dynamics and assessing aquatic habitats, particularly when quantifying the actual volume of water bodies like lagoons. The Vectrino excels in high flow, low sediment environments, providing precise measurements in controlled conditions, while the current meter proves more robust in areas with sparse vegetation and variable settings. Additionally, proper calibration is critical for both devices, ensuring accurate data collection and reinforcing their complementary roles in advancing equihydraulic research and sustainable water management. Thank you very much.
Thank you both for your presentation. So we can go to the third presentation of this session. The title is Hydromorphological Assessment of a Data Deficient Catchment in the RRC Basin. So the speaker is Justin Carey, right?
Yes.
Okay, please start.
Thanks.
Hi everyone, my name is Justine Carey. I'm an Australian working at Boku University in Vienna, Austria. Today I'm presenting my master thesis work, as was already introduced. So just to briefly introduce you to the topic, as you all know, humans are highly dependent on freshwater ecosystems for our survival. However, they are some of the most threatened ecosystems in the world. Recent decades have seen an 83% decline of freshwater biota, and this continues to decline, unfortunately. In recent decades, a field that has emerged to tackle this crisis is that of hydromorphology, which combines hydrology and fluvial geomorphology, basically the form and the water of river systems. And this is the template for biotic and chemical properties to develop. And as such, assessments of hydromorphology are central in holistic, sustainable river basin management strategies, which are necessary to protect freshwater ecosystems. However, unfortunately, in order to undertake these assessments, we need data. And in many areas of the world, there is significant data scarcity. An example of this is in Central Asia. Currently, in international literature, there are no hydromorphological studies incorporating human pressures in any of the 5 countries. However, from what we do know, there are significant pressures on freshwater ecosystems in this region, exemplified by the Aral Sea disaster, which was caused by intensive water abstraction in the Aral Sea basin. So what can we do in this situation? One opportunity that has emerged is increasing availability and accuracy of globally available data sets and models. So in this research, we tested the use of 15 of these data sets in a case study catchment in South Kazakhstan. We used 3 nested scales in this catchment, as you can see in figure 1. So at the first scale, the catchment scale, we looked at land cover change between 1992 and 2020, the hydrological regime, longitudinal barriers, and the water irrigation network. At the segment scale, we looked at a 63-kilometer reach of the Badam River in 1-kilometer segments, and we compared many hydromorphological parameters, including, for example, floodplain width, potential erosion yield, and specific stream power. And we use these parameters as a basis to identify human pressures, and also used these assessment comparing with a study from European pre-industrial alpine rivers. At the third smaller scale, the detailed scale, we assessed a 6-kilometer reach of the Badam River, exploring the correlation between habitat composition and the relationship with large and small-scale water abstractions using random stratified sampling and correlation analyses. So moving on now to the results. So at the largest scale, at the catchment scale, we found that irrigated agriculture was the dominant land cover type in both 1992 and 2020. This was related to an intensive water abstraction network throughout the catchment. We saw a 9% change of land cover throughout the catchment, which was predominantly urbanization along river corridors, and what appeared to be an abandonment of farmland in the headwater reaches with the fall of the Soviet Union in 1991. At the segment scale in the Badam River, we found a range of pattern types, and these strongly resembled European pre-industrial alpine rivers, and we found a dominance of the island-braided pattern. Some of the pressures we identified here were channelization, regulation, urban infrastructure, water abstraction, gravel dredging, and vehicular movements in the floodplain. And then finally, at the third scale, the detailed scale, we found that large and small-scale water abstractions did not correlate significantly with habitat composition changes as we expected. This was likely due to confounding variables, predominantly the 1 to 2 year channel-forming floods, which likely have superimposed any temporary habitat changes, in addition to gravel dredging and regulation structures in the sampled reach. So just to conclude, overall, we found that remotely sensed data was largely adequate for this assessment. However, in order to increase the accuracy, we would require a higher resolution DEM, as currently a 30-meter DEM is available globally. This is not quite enough for what we needed. Additionally, we found that the models relating to erosion and discharge were largely inadequate, and there were strong differences with locally gauged discharge data, for example. So in order to increase the accuracy of this assessment, it would be ideal to have daily time-step discharge data, as well as local geological data and local expert knowledge on vegetation and growth cycles especially. But in general, it's hoped that this research forms a stepping stone in undertaking such analyses anywhere in the world, given the availability of this data, especially in data scarce regions, of which there are many. And it's hoped that with rapidly increasing resolution and data availability, that these assessments can be more accessible and more accurate in the near future. So thank you so much for listening. Welcome any questions.
Thank you, Justin. So the next presentation is tsunami characterization using particle image velocimetry method. And the speaker should be Paola Dasi.
Hi, good afternoon, everyone. Well, my name is Paula, and in this presentation, I will talk about tsunami characterization using a particle image velocimetry method. In this case, it's really important to know that induced forces which are caused by tsunami are critical during the occurrence of the phenomenon. That's why we have used a particle image velocimetry method to obtain velocity profiles. The methodology that we have used involves 4 main steps. The first step is the tsunami wave generation, which long waves, which are similar to tsunami, has been generated with a discharge gate. This discharge gate simulates a dam break, and that's why we are able to generate a long wave. To obtain different measurements of different magnitudes of tsunamis, we have varied 3 different parameters. The first one is the water level upstream the discharge gate. The second one is the water level downstream the discharge gate. And the third one is the gate opening. The second step is the tsunami recording and the video processing. In this case, it's necessary to correct the image distortion and the perspective distortion. And we also have to convert into grayscale all the frames. The picture one shows a post-processing frame from one tsunami recording. The third step is the data analysis. This data analysis was performed using PivLab, which is a MATLAB-based software. And in this case, we choose a region of interest, which is shown in picture 2, where we can see the red area, which is the area that we are not interested in. And in this case, PivLab analyzes every particle and analyze the movement between different frames. In this case, with the particle movement, we can obtain the velocities. And the fourth step is the maximum velocity field. We obtain the maximum velocity for each instant of time, and then we consider the outliers and we remove them. And we apply a triangular moving average to smooth the data. To calibrate our gate, we have tested 78 experiments, and we varied the parameters between 0.3 to 1 meter for the water level upstream the discharge gate, from 0.2 to 0.5 meters for the water level downstream, and we use gate openings between 5 and 30 centimeters. All the velocity profiles have been measured on the internal face of the glass. In the picture 3, we can see the velocity profile for one instant of time. And from this velocity profile, we can choose the maximum velocity, and with all the maximum velocities, we can obtain the maximum velocity field, which is shown in picture 4. In this picture, we can see this maximum velocity field, and we can see the darkest line, which represent the raw data, and we can also see the lightest line, which shows the smoothed maximum horizontal velocity. In this case, for all the experiments, we obtained velocities range from 0.67 meters per second to 3.22 meters per second. And we also obtained some registered surface elevation. We obtained the surface elevation with wave gauges, and these elevations range from 5 centimeters to 23 centimeters. In conclusion, we can obtain a good or a reliable gauge calibration using this non-intrusive methodology to obtain the velocity, and we can also obtain the surface elevation with wave gauges. We can use particle image velocimetry in zones with and without structures, but we have seen that we only obtain good results in presence of bubbles. In that cases where the tsunami doesn't generate a bore, we don't have reliable velocities. And the further steps that we would like to follow is the PIV calibration with experimental measurements to reduce the error and minimize the effect of the different external influences. Thank you.
Thank you, Paola. The next presentation is the necessity of low-impact weirs in Indonesia to balance the weir development and socio-environmental sustainability. Please, James Zulfan, I ask him to join us.
Yeah, thank you very much. Good evening from Sydney, everyone. My name is James Zulfan. I'm PhD student at UNSW Sydney. And yeah, so today I will present my part of my first part of my research about the necessity of low impact weirs in Indonesia. So the motivations of this research comes from the rapid development of hydraulic structures like weirs. And yeah, we all know it used for regulation of water in the river, especially in the global south countries where they're still using weirs for energy generations and water supply and water storage. And so although there are many benefits from the weirs, but there are some concern about whether these structures can cause a negative socio-environmental impacts in the long term, like river fragmentations, water pollutions, disruption of fish migrations, and so on. So more specifically in Indonesia, where currently Indonesia have 1,200 existing weirs, but in the next 10 years, the government already planned to build another 150 new structures in the future. So the question is, how can we make the weir development in a sustainable manner? Because there is no clear guidelines about this yet. So we conduct a literature review from a peer review articles looking at the impact of weirs, best practices from the mitigations that already applied in many projects around the world, and looking at the case of Indonesia, where construction is still popular for water management. As we can see in figure 2, we found some shortcoming or areas that can be improved in the weir design practice in Indonesia. For example, the national guidelines only focus on the technical aspects and lack of socio-environment considerations. More specific, we can say that currently there are no fishway considerations. Although they'll try to there are some cases that they try to put a fishway, but it's not successful. So most of the weir also is a fixed crest and side gates, because probably 80% of the weirs in Indonesia used only for irrigations, which means they tend to have like one size fits all solutions. So therefore, we need to have like a more holistic approach that use a low impact weir design. And low impact weir design is structures that, while fulfilling the primary functions to regulate water, it's also minimize the negative impacts. So unlike the conventional wear that significantly alter the habitat and environment. The low impact wear is designed with a sustainable principles in mind. So in the first time. And yeah, based on the literature review, looking at the figure 3, we identified there are 10 criteria for low impact wears, covering not only the technical aspects that are closely accommodate the environmental issues, for example, from habitat considerations, water quality, hydraulic conditions, sediment transport. We also highlight the flexible operations that are also important to provide safe and optimum flow operations, considering the varied discharge conditions and probably the climate change. Also, the modular approach where we can accommodate or integrate the latest technology material that important to have an adaptable design of structure that can be easily built, easy to install, and easy to remove as it needs. And yeah, we also highlight the importance of the involvement and collaboration of local communities. So social and technical, social and economic aspect is also needs to be considered. And yeah, in conclusions, 10 key criteria already identified, and incorporating this approach to the current design guideline, especially in Indonesia, can be beneficial to have a more adaptable structures. And in the next study, we plan to do stakeholder engagement to look closely at the involvement of communities and conduct a laboratory research to continue providing a more in-depth technical design for low impact wear. Thank you very much.
Thank you very much for your presentation. So now it's time to go to the next presentation, that is re-aeration of NAP flow over a prototype step spillway. The speaker?
Yeah.
Okay. Yeah, thank you.
Good morning and good afternoon, everyone. My name is Tohit Jamadi, and I'm pleased to present our research on re-aeration of NAP flow over a prototype step spillway. This study was conducted at HSE laboratory at the University of Liège as a part of global investigation to quantify how scale effect impact on oxygen transfer in collaboration with FH Aachen University. So re-aeration or oxygen transfer occurs through the air and water interfaces, which is driven by the concentration gradient between the atmospheric oxygen and dissolved oxygen in water. Expanding these interfaces, whether naturally or artificially, enhances oxygen transfer. So step spillway, which are designed as energy dissipator in them, are so effective for re-aerating of water, especially operating in NAP flow regime. In this regime, cascading of water creates extensive air and water interactions, especially in free-falling jets and along downstream surface. However, scaling these flows to the laboratory setup can introduce some discrepancies, especially in air entrainment. So this study aimed to assess re-aeration or aeration efficiency using prototype step spillway in NAP flow regime. First of all, to validate new instrumentation and then find a suitable empirical question in literature that suggested for predicting oxygen transfer in NAP flow regime. This prototype model includes 6 identical steps. Each step measured 0.5 meter in height, 1.87 meter in length, and 0.2 meter in width, and flow rate range 0.2 to 0.6 square meter per second, and dissolved oxygen concentration at the end of a step measured by 8 optical sensor or oximeter. So our result showed that total aeration efficiency increased by 60 to 70% along 6 steps, with the highest increase in step number 2 and step number 3, and lowest in step number 1. Another thing is that with increasing flow rate, aeration, and turbulency increased, but the aeration efficiency decreased due to shorter residency time. And our comparison with the literature formula showed that SRE et al. 1978 and Felder et al. 2019 showed similar trend with our funds, especially for H-time between 1.5 to 3 meter. Also, Baylor et al. Formula showed a little higher values for aeration efficiency for H-time greater than 2 meters, and Kediri et al. Formula didn't get aligned very well with our data. In summary, flow re-aerated by 60 to 70% along the 6th step. Increasing of the flow rate decreased the aeration efficiency due to shorter residency time, and similar trends found with SRE and Felder formulas in the literature. Thank you so much for your attention, and I'm so happy to answer any question if there is.
Thank you very much. So the next presentation is numerical simulations of hydrodynamic drag coefficients for different bar geometries. And the presenter should be Kumuro Osby.
Yes.
Okay.
Thank you.
Start.
So my name is Cumhur Özbey. I'm a PhD student at Hacettepe University from Turkey. Today, I would like to present a numerical investigation, which is about the hydrodynamic drag coefficients for different bar geometries. We have performed numerical simulations to determine the drag coefficients for two different bar geometries. The first one is the Opperman bar profile, which is shown in figure 1. And the second one is the conventional rectangular bar profile. These bar profiles are used at the water intake structures at hydropower plants. And we simulated and we investigated the drag coefficients for these two profiles, and we compared the drag coefficients. For the numerical modeling and to run the simulations, we used Flow3D software, and we applied large eddy simulation with a grid size, with a mesh size of 1 millimeter. And both bar profiles, both the Opperman and the rectangular bar profiles, were located perpendicularly to the approach flow direction. And the upstream flow depth was kept constant at 0.2 meters. And for both bar profiles, the bar thickness values were the same. It is 6 millimeters. We can see the bar thickness as 6 millimeters in figure 1 for the Opperman profile. And this is at the leading edge, actually. At the trailing edge, we have 1.5 millimeters of thickness. But the rectangular profile is only 6 millimeters as the entire profile. The thickness is 6 millimeters for the entire profile. And we have tested numerically 3 different bar spacings, the 4, 6, and 10 millimeters bar spacings under 4 different approach flow velocities, 0.10, 15, 20, and 25 meters per second. So actually these 4 velocities yielded a bar Reynolds number range of 600 to 1,500. We can see it in figure 2 as well. So we correlated the drag coefficients with the bar Reynolds number. It's actually the Reynolds number which is defined for the bar thickness. And if you look at figure 2 for the results, for the main results of this study, we found a very strong correlation between the drag coefficient and the bar shape. We can see that the rectangular bar profiles for all bar spacing values for 6 and 10 millimeters, the rectangular bar profile yielded much higher drag coefficients compared to the Opperman fine screen. And also, so this reveals the correlation between the drag coefficient and the bar shape. Also, if we look at the drag coefficients in terms of the bar Reynolds number, if we increase the bar Reynolds number, we can see that the drag coefficient decreases. But after a certain point, we found that, and it's around 1000, the bar Reynolds number value. If the bar Reynolds number increases after 1000, we observe that the drag coefficient does not change that much. So it almost remains constant. And this is also consistent with the experimental studies in the literature. And also another key findings of this study is for narrower bar spacings, especially for 6 millimeters and 4 millimeters of bar spacings, we obtained much higher drag coefficients. And this is valid for both rectangular and Opperman profiles. And so we can say that this result is also very related with the higher head loss values. From the literature and from our analysis, we obtained very strong correlation between the head loss generated by this profiles and the drag coefficients. So if we have higher drag coefficients, we have similarly very high head loss values, and we can say that the average drag coefficients, this is the main finding of this study, the average drag coefficients for the Opperman and rectangular bar profiles were found as 1.5 and 3.73 respectively. So rectangular bars almost have 2 or 2.5 times more drag coefficients, and also this is valid for the head loss values as well. So we can conclude that the streamlined shape of the Opperman bar profile, as we can see in figure 1, also it triggered a significant hydrodynamic drag reduction if we compare it to the rectangular bars. And this is mainly due to the sharp edges of the rectangular bar profiles, and we observe a very large recirculation zones at the trailing edges of these sharp edges of the rectangular bars. And due to this effect, the Opperman bar profile yields much lower drag coefficients. And that's the end of the presentation. Thank you.
Thank you very much. So now the next presentation is entitled Assessing the Influence of Opening Ratio on Sharp Crest Weir Performance. And the speaker should be Hossein Anzani.
In the name of God, I am Ali Mahdian Khadidi, a PhD candidate of water engineering and hydraulic structures. Hello to all professors at the meeting and also researchers who attend this meeting. I want to present you our research on assessing the influence of opening ratio on sharp crested weir performance. Why we should investigate this? Because as you know, sharp crested weirs are highly used in open channels and for flow measurement in irrigation system. When the width of the width of the weir is smaller than the channel width, it is sharp crested and it has different shapes in cross sections. For example, for rectangular sharp crested, if the width of the crest of the weir is smaller than it, we can call it sharp crested weir. As we investigated into literature review, the effect of opening ratio on sharp crested weir were in few the studies were considered, and because of that, we considered to investigate the effect of opening ratio on the discharge coefficient and discharge of these weirs. Because of that, we considered 32 tests on discharge different from 0.7 to to 4.9 with 4 different P or opening of the sharp cursed there with equals to 17.5, 20, and 22.5 and 25 centimeters. As we can see in figure 2, the width of the thickness of the weir is constant and equals to 3 millimeter, and the height of the weir is P, and it is constant, equals to 10 centimeter. Because the discharge coefficients and has a key role on the results of the sharp cursed weir and performance of the flow on it, we provided the minimum and maximum and average values of CD or discharge coefficients in table 1. As we can see that the CD ranges from the values 0.625 to 0.5191, and the maximum values belongs to 10/15 opening ratio, and the minimum values belongs to 8/21 for opening ratio. And also the effect of head over the weir over to the height of the weir, or HP, H over P, can be important. Because of that, in figure 3, we investigated the effect of head over the weir in comparison with different discharge coefficients, and we can see that H over P with Q are approximately linear in all opening ratio, and also H over P increases by increasing the discharge. As we can see that in the figure 4, discharge coefficient has different variations with H over P, and also the lowest value of discharge coefficients are for the opening ratio 8/24. I want to highlight the results in conclusion, and we can see that the opening ratio increases when it increases, the discharge coefficient increases, and the minimum and maximum values of discharge coefficient relates to the opening ratio of 8/24 and 10/24 with the values of 0.591 and 0.625 respectively, and also the minimum and maximum values of average of CD correspond to these mentioned opening ratio. Thank you for your attention.
Thank you very much. So we can move to the next presentation. It is entitled "The Surface Flow Pattern and Bed Morphology Interdependency in the Vicinity of Hydraulic Structures." The speaker should be Daniel Betts.
Yeah, correct. Thank you for this introduction, and welcome everyone here from Karlsruhe Institute of Technology in Germany. To my presentation on surface flow pattern and bed morphology interdependency in the vicinity of hydraulic structures. And the background of this study is that bed morphology dynamics in the vicinity of hydraulic structures are an important topic in hydraulic engineering, as in the context of structural foundation safety or river revitalization by in-stream measures. And local scour and its related three-dimensional flow field are very complex to measure in the field, and this problem can be overcome if there is a possibility to infer bad characteristics from readily available data like two-dimensional surface flow fields or free surface elevations. And in this context, since existing literature is very limited, we experimentally explored the interaction between surface flow characteristics and the associated bed dynamics in the vicinity of a circular pier, with the aim to contribute to a hydraulically based approach for river engineering praxis, linking the surface flow and bed morphology in the vicinity of hydraulic structures. As methods, we used lab experiments under clear water conditions with different hydraulic conditions in the poster indicated as HC1 and HC2. And we used different measurements at different scour development stages, where the T0 case is the pre-scour flat bed situation, T1 corresponds to 70 and T2 to 90% of the equilibrium scour depth. And as measurement techniques, we used the surface PAV to assess the surface flow field, a grid of ultrasonic sensors to measure the free surface elevation, and the structure from motion approach to reconstruct the bed morphology. And as a brief insight into these results, figure 1a displays the superposition of normalized bed morphology as a contour plot in the background and centerline symmetric normalized mean surface flow field as vectors and different definitions of the wake boundary for two of the experimental cases. And the results show that the surface flow changes with an advancing scour process as follows. The mean flow approach velocity increases, whereas the mean wake surrounding flow velocity decreases, and the same is valid for the minimum structure near surface velocities. The wake shape changes from a circular pier-wide straight to an expanded shape that is driven by the erosion deposition morphology in the wake zone, and the wake shear layer definitions based on flow velocity recovery and vorticities diverge spatially with increasing scour. The backwater rise decreases and the near wake free surface elevation decline below the uniform flow water level is only observable for a flatbed case, and is the higher above it, the higher or the further advanced the scour is. And no additional findings could be deduced from surface turbulence metrics. From these findings, the following bed morphology surface flow relations could be inferred. The first possibility is to distinguish between flat and scour bed based on the wake shape or based on the free surface elevation in the near wake zone. An additional recommendation is to do a qualitative tracking of the scour development based on the surface flow velocity distribution, and we proposed a quantitative relation to infer the current scour depth based on the backwater rise from readily available data and subject to the circular pier upstream measuring distance outside the bow wave. And for this relation, we can see in figure 1b an exemplary quantitative relation of this type between the backwater rise and double normalized current scour depth. And a similar relation as shown in figure 1b can be derived for each upstream position within the backwater rise zone and outside of the bow wave. We approach a general relation which however lacks sufficient validation due to too few upstream measurement points in our study. It must be noted that all these findings are subjected to some laboratory study-based limitations, and furthermore the surface PAV technique is quantitatively reliable only in shallow flows, and thus the surface PAV results in our study were only used for qualitatively deriving bed morphology surface flow relations. So it can be summarized that these outcomes are a proof of proof of concept of a simple, efficient, and hydraulically based bed morphology assessment around hydraulic structures that can also be applied in river engineering praxis. Thank you for your attention, and thanks for all upcoming questions.
Thank you very much, Daniel. So I think that we don't have nobody for the next presentation, but the title is Numerical Investigation on the Efficiency of Tuned Liquid Dampers as Structural Vibration Control. So is there anyone who has to present this, this presentation?
If so, in the audience, please raise your hands.
Okay, so we skip to the next one.
Okay. The next and the last presentation is modeling the impacts of a storm surge barrier on the hydrodynamic regime of the Ham Luang estuary. So
hello, it's me. It's my.
Okay, hi Fam. Okay, thank you.
Can you hear me? Sweet. Can you hear me? Okay.
Yes.
So, okay. So, hello. Today to talking about the model impact of the storm struggle barrier on the hydrodynamics premiere of the Ham Luang estuary. So first one, I want to introduce that I'm Hai, is a person who presents from water resources, and according I'm from Vietnam. So talk about the contents, the Mekong details that in fact in a significant challenge related to water resources, the construction of the numerous the hydropower dam in the upstream area has elected and continue to enter the flood push reaching the detail. The Mekong details that's one of the world the fastest and the lowest lying the coastal plannings with an evolution of approximately around 0.5 meter above sea level and a gentle slope around 1/1000. This makes the reason practically to number able to coastal flooding included by a storm struggle. So the development of the multifunctional storm struggle barrier as a flood defense solution is necessary. However, the battery of the debated due to their potential ecological and environmental impact. The methodological. So this study developed a numerical model of the Ham Luang estuary using a depth 3D software. The models were designed with two computational domains. The first one that is a ledge domain. The second one we use a estuary domain. So the ledge domain we have extended to embodiment of the effect tidal function at the upstream boundary, and the estuary domain we have the refined GIF with a higher resolution, allowing the detailed simulation of the flow field within the estuary area. The thing one illustrates to the computational GIF of the two domain. The Y finger tool that presents the computational GIF and the boundary of the estuary area, along with the battery matrix interpolated into the GIF cells finger 3. So the simulate flow field within the estuary area when a storm struggle barrier presents. The simulation result indicated that knowing the estuary cross-section due to the barrier construction lead to approximately double length of the flow velocity during the tide periods. Therefore, when designing the structure, it estuary consider the adjustment to get opening the the structure to minimize the impact on the river and the tidal flow. This approach can help to reduce the effect on the hydrodynamics and morphological condition of the estuary, the carbidation and virgulidation. So we not mention, we not have a detail about the calibration and validation result. However, the model has been calibrated and validated using the measured data from the study area to ensuring the reliabilities for the analysis constructed. So that is the end of my presentations. And if you have any questions, so below in the chat. So thank you.
So thank you, Haifa. So maybe the speaker of the presentation entitled Numerical Investigation of the Efficiency of Tuned Liquid Dampers as Structural Vibration Control is arrived. So no? Okay, because I saw a hand raised, but okay, anyway, we can go to the second part of this session. So I ask Stefan to chair.
Yeah, thank you very much, Nadia. And thanks very much to all the speakers. So this was very impressive, very nice mixture of presentations, topics, but I thought you all presented extremely well. So great session. So in this question and answer or coffee chat, it would be great if all speakers put their cameras on so that we can have a bit of a discussion. There were several questions posted in the chat, but I think all speakers have the chance to ask questions as well. So it would be good to have a bit of a discussion or, yeah, vibrant questions from your end as well. Should we start with the first speaker? Maybe we've got a question for the first speaker and then we move through. So the first speaker was, wrong screen, was Ivan Humam. Any questions for Ivan? Or any comments on his presentation? So that was the X-Beach model performance with the X-band radar data during flood events. If nobody has a comment, I've got a question. So did you actually, so you use radar data. Did you confirm the accuracy with any other technology to actually have a ground truth?
Okay, so the accuracy I already researched about it and also published in some of the journal. So I also validate the velocity from the X-band radar using indirectly validation. So for the velocity obtained from the X-band radar, we can estimate the water level. Because we have a cross section and also the discharge and also the velocity, and we can estimate the water level. And then from the water level, we can compare with the observed water level in the field. And the result is relatively similar. So for the velocity, we can conclude that the accuracy of the velocity obtained from the X-band radar is reasonable. And also for the morphological change, I also published some paper on it. So I compare the velocity in the sand dune tips and also the changing rate of the sand dune tip using X-band radar. And the correlation is relatively similar. So when the velocity reach up to 2 meters per second, so the sand dune tips or sand dune is eroded extremely if the velocity extended for the long time. But for the short time, the rate of the erosion in the sand dune is very small. So I can assess the accuracy from the velocity and also the morphology based on my explained before. Thank you, Professor.
Yeah,
But
thanks very much.
yeah,
Uh,
yeah.
yeah, there were several other presentations who used PIV or surface PIV, surface velocity measurements. Did you have similar experience in terms of accuracy or any comments on how your measurements compare to what Ivan was mentioning?
So for because the X-band radar is I think it's relatively rare using X-band radar to observe the flow velocity. So compare from the other research, for example, using drone or action camera, it's drone and action camera also can estimate the flow velocity using PIV, actually using LSPIV, but the limitation of the drone and also the action camera is cannot obtain in the night time and also during the storm and flood, which is the wind is not stable, the instrument is difficult to obtain. So X-band radar may be possible option for measuring the flow velocity during the flood or extreme conditions such as storm or coastal floods, something like this.
Yeah, thanks, Ivan. I was wondering also some of the other presenters. I think Daniel Betts used free surface velocimetry, and there were, I think, at least one or two others. So any comments from any of the other panelists in their experimental study in terms of experience on using this type of free surface instrumentation?
Yeah, maybe in our study. So I would say the applicability of surface PIV is rather limited to easy flow conditions, especially especially when considering flows around structures, as in our case. So due to the intrinsic lack of the third dimension of this technique, we decided to only use it for cases where we can clearly assume a two-dimensional flow field, and for other flow cases only to use it in a qualitative way. Since we could show in our experiments, or also in other experiments that I did not present today, that the qualitative results from surface PIV are okay, also for complex flow conditions, but do not allow to extract any kinds of magnitude of flow velocities or related statistics. Yeah, that's the way we treated this methodology.
Okay. Thank you. Any comments from anybody else on measurements of velocities? More widely, maybe, on your experience.
Well, in our case, we have measured flow velocities with PIV, and we have seen that there are good, reliable measurements when we have bubbles or some trace particles, but we are not sure if we can measure it in a channel because we have a very big width, and in that case we don't know the position of our particle. So I think PIV is a reliable